presentation to give an overview about the document, and then a panel discussion. And after these two blocks, we enter into more the a presentation from Chiara Ferrari and Valentin J. Blanchard, who will give more an overview of how we could keep this bottom-up collaboration, this community of practice, alive in the future after the end of the project. And then I will have a short closing remarks. And so that's my last slide. I would suggest now to invite our first keynote speaker, Pantelis, and perfect. Thank you. Merci. Okay, now I will hand over the stage to Pantelis Tziveloglou for a presentation from the GRTD on the two words, a common European data space for research.
Thank you very much, Sergio. And thank you also for the invitation. It's a pleasure to be here, to be given the opportunity to say a few words about the work that we are doing in the European Commission to support what we call a common European data space for research, which is the European Open Science Cloud. Maybe most of you are familiar with the European Open Science Cloud. This is a slide to introduce a little bit the concept. It's been around for several years. The initiative started almost a decade ago. And a significant change in the last 2 years was the development of the EOSC Federation. What I want to highlight with this slide is that EOSC is not only the EOSC Federation, it is a broader, let's say, policy vehicle that we use in order to promote any kind of practices that around data management in line with the FAIR principles and the infrastructure that are necessary to achieve this. So yes, it is about developing an infrastructure, which is what I highlight in the first part of this slide. So a pan-European system connecting research data and services, and this is what we're trying to do with the EOSC Federation. But at the same time, it involves a much broader community of the several hundred of organizations we currently have being supported by the EOSC projects and any other infrastructure organization in Europe that is dealing with responsible management of research data and the application of the FAIR principles. I will say a few words more about the EOSC Federation. I think it's an important development of the past 2 years. But before going there, I wanted to highlight a little bit the policy framing for the European Open Science Cloud or the Common European Data Space for Research, starting with providing a slide that opens a little bit the scope. All the slides that come after will be about EOSC. Here, I just wanted to highlight that EOSC is not the only thing that we are doing in my service to support open science. It is not enough to have only EOSC. We need to have also activities around promoting open access, and we are working on this. Also, research assessment is an important element that we are trying to support through the Coalition for Advancing Research Assessment. Aspects related to the legislative and regulatory environment for practicing open science, specifically for what concerns the management of data and the management of rights of researchers for their outputs, as well as public engagement and research innovation and citizen science. So these are other types of activities that we are engaged, and we try to support the community in order to foster the cultural change that is needed to move towards open science, to move towards more responsible management of research data. Now, looking into the policy landscape within which EOSC sits, first and foremost, what we highlight is the European research area. So this is the overarching policy for research at the European Union level. We currently are under the European Research Area Policy Agenda for 2025-2027, and for us, this and the other policy initiatives I highlight are extremely important because these are allowing us to then follow up with specific implementation and support measures of what is already included in these strategies. So what we have here is a collection of structural policies and actions in the policy agenda. As you can see, open science, data sharing, and the European Open Science Cloud is the first structural policy highlighted in the ERA policy agenda, which is the hook that we have in the overall policy frame for research in Europe, for following up with support actions on the European Open Science Cloud, but most broadly on the FAIR principles. So here is how the first action of the policy agenda looks like. It's the structural policy one and the expected outcomes that are identified. So this also comes through a process where the Commission is setting up a communication, but then also the Council, that means the Member States, are taking up this input and they're developing their own conclusions. And what you see here is also including this input coming from the Member States. So the highlights here are the development of the EOSC Federation, the focus on the FAIR research data, so the FAIR agenda at large, but also looking into copyright and data framework and ways to better monitor and assess the impact of open science so that we can better inform policy development in the future. So these are the broad lines of activity that we can identify in the ERA policy agenda for what concerns the development of open science, of data sharing and EOSC. But it's not the only high-level policy strategy that where EOSC is highlighted at EU level. Here we highlight three more other strategies. These are coming from different angles. The first one is more on the infrastructure side, so it's the European Strategy on Research and Technology Infrastructure. It was published last year, where again the EOSC Federation is identified as one of the main aspects for what concerns the digitalization of research infrastructures in Europe. Again, in alignment with the ERA policy agenda, we highlight the need to sustain and enhance the EOSC Federation, to support compliance with the FAIR principles, and also looking towards supporting the development of AI for science, which links also to the other two strategies highlighted here. The first one is the AI in Science strategy, with a flagship initiative called RAISE. Some of you, maybe colleagues from EGI, may be familiar because there is also a bunch of actions supported under the AI in Science strategy in Horizon Europe, to which some of research organizations, including those in this project, are participating. And then the Data Union strategy, which is also aligned with the AI in Science strategy. The main element that we find in this strategy is that is linking the development of AI in Science and EuroHPC with EOSC is the concept of data labs. So these are services that are aiming to make the link between the data spaces. EOSC is one, but there is more data spaces developed in different sectors in Europe, and the AI factories and the EuroHPC facilities for what concerns the computing and the computing capacity. So this is more or less the landscape. Of course, I highlight here some older but very influential reports that came from Mr. Letta, Draghi, and Haytor 1 year and a half ago. These are highly influential. They go into the overall future of Europe, and they have been very much influencing the development of the overall multi-annual financial framework, of which Horizon Europe, the new Horizon Europe, is one component. And there again, we see a strong reference to development of federations of data in Europe, scaling up infrastructures in order to be able to compete also with other important scientific powerhouses in the world. So, closing this overall policy framing, I wanted to say a few words about the work that we are doing around EOSC and the EOSC Federation in particular, starting with the governance aspects. I saw in the research agenda of Spectrum that governance is an important priority in one of the 13 priorities that you highlight. And this is something we have seen also in our work with EOSC, that setting out a clear governance is absolutely crucial in order to be able to get all the players in place and hear the voices both of at the European level, the voices coming from the countries, so the national funders, the national policymakers, but most importantly, the voice of the community itself. Now, the way we try to bring all these voices together is through this so-called EOSC tripartite governance, where the Commission is represented, as well as the Member States and the associated countries. In order to bring the voice of the Member States, we set up what we call a Commission expert group. Every member is a representative of a country. It's an advisory group of the Commission, and we have this group participating in this tripartite governance. And then the EOSC Association is an organization of around 250 members that is also bringing the voice of the community. The members are mainly research organizations, universities, infrastructures, funders of research in Europe. And here is just a highlighted list of activities that we are undertaking in this EOSC tripartite governance. First and foremost, it allowed us to secure funding at a seven-year timeline, which is critical in order to get this kind of safety of funding, let's say, in the long term, starting in 2021 with the establishment of the EOSC partnership. So this was a partnership between the Commission and the EOSC Association, and part of this partnership was a commitment by the Commission to support with around 500 million euros the development of EOSC throughout the Horizon Europe. So what you would see as projects, as calls coming under Horizon Europe in EOSC are basically the implementation of the commitment that we put in that partnership. And this allowed us to have a very stable funding for 7 years. Then, as part of this partnership, there is a strategic agenda for the development of EOSC. Also, the community input for EOSC in Horizon Europe. So the EOSC Association is organizing stakeholder consultations, providing input for the work program development, which is with the Commission. And this is something we take into account when we develop topics and calls in the coming years. From the side of the Member States, of course, we have the strategic advice and the national coordination mechanisms, and a number of policy opinions that the members, the countries are publishing. We had around 8-9 such policy papers coming in the past years in various aspects. The latest one was on data sovereignty, which is a kind of overarching priority that's becoming increasingly relevant for EOSC. Then we're also working on monitoring open science across Europe with the EOSC Open Science Observatory and other aspects, and most importantly also the EOSC post-27 discussion, which is our overarching deliberation of what should be the next step for the new Horizon Europe that will start in 2028 for EOSC. I will come back to this point at the last slides looking into the future outlook. Now moving towards the EOSC Federation and starting with the EOSC EU node. This was the first node of the EOSC Federation that was put online in October 2024. It is owned by the Commission. It is based on a procurement, so it's managed services by the Commission. And what we have done through this procurement is to provide services to researchers. So these are standard collaboration services such as sharing files, computing, storing files, etc. But also providing federating and core capabilities in order to be able to connect different nodes together. And the focus there is mainly on AAI, so authentication and authorization infrastructure, catalogs, so federating catalogs of services and of other types of resources of the different nodes into a common EOSC catalog, but also monitoring and accounting for the services that are being offered. This is how it looks if you connect to the EU node. Any researcher in Europe, in principle, has access to the EU node and can benefit from the service that it offers. It works on the basis of credits, so you enter, the system identifies you as a researcher, and therefore you get a certain allocation of credits that are replenished every 3 months. And you can burn this credit against specific services that are offered by the EU node. And this is how it looks when you enter into the dashboard. But the EU node, of course, doesn't make a federation, right? So the next step for us was to open a call for expressions of interest for other organizations that are willing to join into the process of building a federation. We don't have a federation at this stage. And this process ended up with the identification of a number of organizations, what we call the first wave of EOSC nodes, which you can see in the big box at the top right corner. So that was around a year ago. It was in March 2025 when we kicked off the process of building a federation together with these organizations. This is mainly based on voluntary contributions from these organizations. There was no specific dedicated funding for these organizations to participate in this effort. And then last year, we opened the second call in order to bring more organizations into the EOS Federation. The results came out last April, and as of the previous month, the second wave candidate nodes are also starting to be engaged in the Federation. What you see here is where these second wave nodes are coming from. So we have a bunch of national nodes, Czechia, Croatia, Latvia, North Macedonia, Sweden, Slovenia, Switzerland, and Turkey, but also a number of e-infrastructure and thematic nodes, including EGI, GEANT, and other organizations. So we hope to get these new nodes on board as soon as possible so that they can also start contributing in the building of the Federation. And the objectives that we have set up for this year is to take this building phase into a more operational phase, to migrate the build-up group into a group that is managed by the nodes of the Federation and the EOSC Association. To this end, all nodes together and the EOSC Association signed the Memorandum of Understanding that sets a kind of a governance structure for this for the Federation, but also to move into production. So what I mentioned before, the AAI, the catalogs, the registry of the nodes into the common registry of the Federation, all these are work in progress. So what we want is, before the end of the year, to be able to say that we have all these elements in production. It's interesting to see that some elements like AAI federations are also highlighted in your research agenda, and I think there is some alignment in terms of what you identify as priorities and what EOSC is delivering within the EOSC Federation. And then the rest is about further expansion of the Federation. Of course, we now have 28 nodes, 14 from the first wave and 14 that are now slowly, kind of gradually entering from the second wave. And the aim, of course, is to bring more nodes in scope, but also to provide organizations that are not necessarily interested in participating as a node to find a pathway to offer their resources to contribute to the development of the Federation. And this we haven't really fully developed yet, but it should be done. And it is about onboarding your resources into an existing node by participating in a consortium, for example, that can set up a node. So this is another alternative pathway, maybe more, I would say, lightweight for organizations, for universities, for kind of for infrastructures that have an interesting service or an interesting data repository to make it available into the EOS Federation. Going back into the governance aspects, because again, this is something that I saw was highlighted in the research agenda. This is just a quick flash of how the current Federation is being organized. I mentioned the MOU, so the nodes and the association worked into a kind of an organizational structure. We have a committee of the coordinators of each node, a committee of the operations for the Federation, and then a number of working groups. And maybe there you will find some working groups that are dedicated into elements that are also highlighted in the SRIDA of your project. Architecture and federating policies, very important. Also the authentication authorization infrastructure, the catalogs, file sync and share, federated compute and storage aspects, of course, training and competencies. There is a working group specifically focused on that. Cybersecurity, legal and governance aspects is also very important. Not all of these groups are currently in place. Some of them are being proposed, and they have to be accepted by the coordinators committee in order to become activated. But the idea is to use this structure as much as possible to be able to move forward with the development and with the transition to production of the Federation. Closing now the chapter on Federation and moving into how we support the development of EOSC through Horizon Europe. Here is the overview of the 500 million support to EOSC in Horizon Europe that I mentioned before as part of the EOSC partnership. During the first 4 years of Horizon Europe, we had a bunch of topics. They ended up in the funding of 34 grants, including a grant around science clusters. And here, just to highlight that an important grant that was from the previous framework program to Horizon 2020 was funding ESCAPE, and I was bringing together the particle physics and astronomy community into building a science cluster. And this community, I understand, is also kind of continuing its coordination and is also included together with the other science clusters that were funded by that call in a project that is now running, which is called Oscars. So this is just to give a highlight of how the physics and astronomy community is also included in the funding that is provided through the EOSC calls. But more importantly, looking forward, in 2025 we have 5 topics. These have led to 13 new projects. These projects are kicking off as we speak. Some of them are kicking off before summer, but most of them will be kicking right after summer. And there we have topics around supporting the federation, but also on AI, so the links of developing services that are using the ones that are being provided by organizations participating in the EOS community for either for the third topic that you see highlighted here on advancing the AI readiness and the machine actionability in the EOS ecosystem. So this includes AI tools to make data more fair, but also services, AI services that are used by researchers. And then there is another topic, the fifth one, is that is more focused on generative AI model. So this is also linking with another initiative of a European initiative called Generative AI for EU. For what concerns 26-27, we have 4 topics. The 2 topics under 26 are closing in a couple of weeks. The first one is on the uptake of fair data management practices and EOSC by research communities, which includes an important part of the overall budget, which is 40 million. Around, I think 29 of this million will be diverted towards cascade funding for open science projects of around 200,000 per project, which is an important opportunity for the broader community to benefit from organizations that aren't participating in the Horizon project itself, but in the cascading grants. This is using an approach that we tested with the current Oscars project of cascade funding and open science projects that proved quite successful. We had a very high number of proposals coming for these open science projects, and we wanted to continue this approach, and this is what this topic is about. And then in 2027, maybe to highlight the third topic here, expanding and deepening the EOS Federation. It is a quite important topic for 2 reasons. First, the budget is quite high, 40 million coming from the European Union side, and 40 more million, and that's the other novelty of this topic, coming from member states, because we plan to have this topic as a co-fund action. So we want to bring national funders to co-fund with us the publication of joint calls through which multiple organizations in Europe can benefit from. And the focus here is on providing digital services to researchers. So it goes into also cloud type services, compute storage, or other types of services that researchers may need. So the other component is the development of EOSC nodes and the support for EOSC nodes, but also this kind of digital services provision is, I think, important to highlight. And then there is a procurement of for the continuation of the EU node that is foreseen for this year, and in fact the publication came out just a few days ago of the procurement. So this information is already now public. This is just flashing out all the projects that are running since 2020 in Horizon Europe, so since early 2022. Some of them have already closed, some of them are about to close, and we are now going to add the new projects that are coming from the 2025 calls. And before closing, just a few words on a future outlook for EOSC. Here you see the structure that the Commission has proposed for the new Horizon Europe, the one that will run from 2028 until 2034. Some elements are similar, some elements are new. What is important for what concerns research data, EOSC in particular, is Pillar 4 and the specific part of Pillar 4 on research and technology infrastructures. In the Commission proposal for the new Horizon Europe, there is explicit reference to EOSC, which kind of reconfirms our commitment to continue to support the development of EOSC. So what we want is to see the support to EOSC to be channeled through this part of Horizon Europe. Of course, this is the Commission proposal, it's not the final program. The proposal is now discussed with the Member States and with the European Parliament, and we hope to get the final regulation and the overall legal base of the new Horizon Europe published in the coming around 1 year. An important component of this discussion is the discussion of whether there will be a new wave of partnerships in the new Horizon Europe. As I highlighted before, EOSC is a partnership in the current Horizon Europe, so we are now discussing with the countries and with the community through the EOSC Association on what would be the position, the best position for EOSC in order to be able to benefit from this discussion on the partnerships portfolio in the new Horizon Europe. For what concerns the directions for EOSC, what we see highlighted here, which is what has been highlighted also in some of these aspects are highlighted in the high-level policy documents I mentioned before, so the ERA policy agenda, the strategy for AI, is to sustain and enhance the EOSC Federation, make sure that we bring in the users, we make sure that there's a strong uptake of what is being developed. This is important to make the link between digital infrastructures and the tendency of infrastructures to develop services that are based on their technical capabilities, matching, though, the needs of researchers. So having also a strong pull by scientific use cases, and this is, I think, what is important also from projects like Spectrum to bring these two elements together, the scientific needs and the digital infrastructures. Then, of course, the AI is an important parameter that is increasingly central in the overall development of EOSC. Another key consideration since a year and a half is the data sovereignty. This is started as a reaction towards what was happening on the other side of the Atlantic, with many important data repositories being either shut down or influenced or altered or even skewed, coming from political pressure. And then it evolved into a broader question of how we can enforce data sovereignty in Europe, especially for data that are critical for research, to make sure that we don't have extreme dependencies on players outside Europe that are not always aligning with our own approach or our own values. So this is something that we are taking very much into account, and we want to see how EOSC can best support the overall reinforcement of data repositories that are critical for research in Europe. And then, of course, EOSC is not developing in isolation. We see other major players being developed at European level. EuroHPC is one of them. RAISE, that I mentioned before, is now an emerging new important initiative. The other data spaces that are coming up, there's more than 10 of them next to EOSC. So it's important to make sure that all this complex ecosystem that is being developed has some level of coordination and alignment so that we can benefit also from synergies between the different initiatives. And of course, this is an open question also to get your feedback. We need this feedback from the community, from the experts. The experts are you, to let us know what other priorities need to be highlighted for the development of EOSC, and work like Spectrum, developing a roadmap, and the research agenda are very important for us as input for our further development of the European Open Science Cloud, but also of how we can materialize these links with the other initiatives like EuroHPC and the data spaces. So these are the points that I wanted to make. Thank you very much.
Maybe we have a couple of minutes to pick up some questions. Do you have any questions? Okay, Tommaso.
Tommaso, INFN. Clearly, you caught me by surprise because I was going to ask you the same thing you just asked us at the end. So you know that we are sciences which are both data intensive, so we will need access to large repository catalogs, which is probably going through the EOSC at some point, but also large processing capabilities, and this is EuroHPC today. So how do you see the connection between them? Should the EuroHPC be seen via the EOSC to us? How is the connection for you?
The connection is a well, we have to identify the complexity of the system and that the connection is evolving as we speak, right? So if this discussion was done 2 years ago, 1 year ago, it would be a different approach. What we see is needed is to make sure that there is a certain level of technical interoperability between the main technology solutions that are being adopted by EOSC and those that by EuroHPC and the other important initiatives. Now, the question that is important and what was coming from my end is that in order to be making wise decisions about what should be the right solutions to deploy, we need to have the right science cases behind us and backing us, right? And EuroHPC is moving towards a direction that is not only serving researchers with the AI factories and the gigafactories that are coming up, it's also moving towards serving industrial players. So they have different communities in mind for serving. So what we want from the side of RTD and from the side of EOSC is to make sure that the voice of the researchers is heard and that is taken into account into the overall alignment and coordination of these initiatives, right? Now, how this is done in practice, I think, is by raising your voice, by advocating, and by participating in these initiatives that I highlighted, especially from our end, this would be the EOSC, right? So to bring this input and to express your needs, like the ones that you highlighted, especially for data-intensive disciplines that make use of these resources the most, to bring these needs into our attention so that we can also bring to the attention of the political masters and make sure that they are included in the overall agenda, the overall strategy for the development of these initiatives. It's not easy. It is continuously evolving, and it's also different players involved. You know, EuroHPC, it's many DGs being involved and many players also outside the European Commission. So getting an overall coordination and kind of harmonization of all this is absolutely not trivial. But this is, I think, how we should move.
Yes, Raymond Ong from SURF. Just to continue on that topic a bit, you started your talk by saying that the data labs may actually provide one of these interfaces. How do you actually see this how the data labs are connecting both to EOSC and to EuroHPC, and what is the path forward there and the influence that EOSC will have on developing the data labs?
Yes, so the data labs is a quite new concept. In fact, it was introduced last year. So we don't have a specific implementation of data lab right now in place. However, there is kind of specific initiatives that are being now deployed in order to set up the first data labs. The concept is to make the bridge between the data spaces, which are their core business is to manage the data. So this is about interoperability of the data and bringing the data repositories together, and the computing capacities that are coming from the EuroHPC and the AI factories, right? And this bridging kind of includes a certain number of services, pseudonymization services for what concerns personal data, preparation of the data for consumption by AI models for training. So a kind of whole bouquet of services that this data lab will offer to make it easier for the users, or in our case, researchers of data, to make it easier for them to be able to use the services that are provided by EuroHPC. In our case, we want to work on a needs-based approach, so to see what is really the priority needs of researchers in order to be able to make better use of the computing capacity provided by EuroHPC and to build a data lab concept around these needs, which is, as I said, we don't have a specific implementation plan in place now, but this is something that should be coming up very soon. I would expect that the first way is to bring together the community to identify these needs and then to come up with a proposed technical solution, right?
We have a very nice SRIDA for the needs.
Hermann Hessling, German Center for Astrophysics. Current large research infrastructures are large international infrastructures. How will the future funding of the European Commission differentiate between local support and indirectly global support of certain science?
Local and global. Local, I guess, in our context, is European versus
Yes.
global, right?
Okay, yes.
Well, the Commission, the Horizon Europe and the Union at large, they have both supported initiatives that are truly European, but they also contribute to global initiatives. Take, for example, CERN. CERN is a very important participant in Horizon Europe projects, but of course CERN is not only EU member states. It includes also many countries, and many countries benefit from CERN outside Europe. I think the approach would be to make sure that both channels are open. It is important for us to be able to develop and support a European inbred capacity. This becomes increasingly important now, seeing that other players are changing their mind on how we participate and cooperate in par with them. So we need to make sure that these investments are made so that there is a certain capacity in Europe to especially for what concerns the more critical data for research, to be able to secure the access to this data by European researchers, by researchers in Europe. But at the same time, this is not isolating Europe with respect to the rest of the world. We need to make sure that we are raising, we are extending hands of cooperation with other like-minded countries for global cooperation. And we have seen this happening in many cases in the past. And I think it's important to continue to also support this kind of cooperation channels.
Thank you.
Thank you. So just to thank again our speaker. We'll have more chance later, also during the lunch. Later we'll have a networking session as well. And my suggestion now is to have a short break. We anticipate the break to now, and then we continue with the next keynote. We can have 20 minutes break, and we can resume at 11:20. Thank you. There's some coffee outside and sweets, fruits. Keynote, which is part of the agenda. We will have a very interesting presentation from Professor Estela Suarez from the Jülich Supercomputing Center and the University of Bonn about the shaping the European post-exascale future. And I'll leave the stage to Estela.
Well, thank you very much. Well, the title is a bit ambitious, I guess. I'm not sure if the presentation will stand up to the target, but so I will speak in my role as the chair of the RIAC, so the Research and Innovation Advisory Group. I've been chair of this group for 2 years, and what I'm presenting here is some of the things we have recommended looking towards for post-exascale, okay? So my plan is to give a bit of background around EuroHPC. I think that most of you will know it, but just to put everybody on the same place. What was the motivation? What is the role of these advisory boards from which I've been participating in? I did some kind of analysis of the funding distribution in the past years, and then looking for the post-exascale, what we have recommended for now, what is coming up. So started by EuroHPC, the motivation of creating this entity, this joint undertaking, is basically the amount of budget that is required nowadays for driving HPC. So in exascale, pre-exascale, infrastructures are very expensive, but also research initiatives require a lot of investment. And it is something that even for an economically powerful country, like for example Germany, cannot be doing on its own. So the idea was, let's create a central entity, kind of a piggy bank, that is EuroHPC, in which the European Commission puts a bunch of budget, and the member states match this funding with equal amount. So it's half of the funding is coming directly from the European Commission, the other half is coming from the member states, which by now are around 38. And then there is also contribution from the private members. The numbers you see here were the originally foreseen ones. The specific numbers have changed now with the AI factories and with the AI gigafactories, and also the distribution of this funding has changed a bit. But that's the general principle. The general principle is to have a central entity that coordinates and manages projects and infrastructure deployments at European level. So the activities that run under EuroHPC are grouped into the so-called 7 pillars. The pillars are infrastructure, AI factories, federation and hyperconnectivity, technology, applications, skills and usage, and international cooperation. There has been recently the addition of two additional topics, the gigafactories and also quantum technologies, that, well, I'm not sure if they will be structured exactly as pillars, but they kind of add into this context. And then the governance of this EuroHPC is so that you have a governing board in which you have members from the European Commission and all these member states. Members typically are representatives from the ministries that take the decision. So they decide where the investment is going to, which kind of calls for proposals are being put out, and they give then the mandate to the executive director and his team to execute these decisions. The role of the industrial and advisory and scientific advisory groups, which are INFRAG, RIAC, and now has been added this QTAG. So INFRAG stands for Infrastructure Advisory Group, RIAC for Research and Innovation Advisory Group, and QTAG is for Quantum Technology Advisory Group. So in the past, we had only this one. I was sitting in this one. Our role is to give recommendations, to bring the feedback and the input from the wider HPC community and give recommendations on where we think are the priorities in which the investment should go. We do this through this multi-annual strategy program that is a document updated every year, where we think that things need to be updated as things evolve. We also give feedback to call text when the governing board thinks we need some advice. We are not sure if that's the right shape for a given project, for a given call, and they ask the advisory boards. What we have tried to do for the last 2 years is to bring the voice of the HPC community. So we have been doing consultations. We have every Wednesday at Open Cafe where we invite sometimes people from the community to speak about some specific topic. And we have taken this input as part of our recommendations. So my advice here, or my recommendation, is that your communities, if you want to give feedback, if you want to give input to this process, get in contact with the advisory groups members, which are published on the website. You can contact any one of them, and hopefully they will take then your input into account. So within this context, I have been looking into how funding is being distributed within EuroHPC. And I have to be clear that this is data that I have collected by myself. I've tried to do a best effort and an honest analysis of the data that is publicly available out there. I focused in EuroHPC alone. I know there is funding from HPC in also the European Commission, but I didn't have the easy possibility to find all the different sources together. So I looked into basically these 3 sources, which are the website from EuroHPC, the participant portal from the European Commission, and this TED is the tenders, the place where the infrastructure calls are being, for procurement are being published. And my goal is to get an idea of the general trends. So how is overall the distribution? I'm sure it's not 100% correct, but I try to do this as precise as possible to get an idea of how things are evolving. Important is for me to say that this data has not been checked nor approved by EuroHPC or anyone else. So it's really my personal analysis, and I give this to you just information. Please don't hang me, if possible, if at all possible. I collected this data in May, and of course, this will continue evolving. And I did this manually. I actually tried some LLMs, but what I got was so unreliable that I didn't feel confident to use it at all. And I report easy contribution. You could it was easier to find this information. You could do this, in terms of absolute numbers, it's more or less a factor 2, if you want to know the absolute numbers. It's not exactly, but kind of approximate. I will not go into the details, but I guess the slides can be shared, how I did the analysis, and if anyone wants to have the data, I'm happy to share it. So how I looked into the sources, what I looked for there, I looked for calls and for granted projects, what was the volume, when they started, and things like that. And then I classified these pillars in kind of 3 blocks. So I took as infrastructures, the infrastructure itself, the AI factories, and the federation. I took as R&D applications and technology, and I consider just skills cooperation as kind of a 3rd additional category. And then I look into the calls and into the projects and try to classify them into these 3 blobs, depending on the title, the context, and so on. And that's what I found. So looking into data from 2020 until now, until 2026, what I got is that around 70% of the money goes into infrastructures, around 1/4 into R&D, and around 7% into skills and cooperation. One important thing to know here is that on the infrastructure side, I have not included the AI gigafactories because this data is not yet really solid. So call is more or less, the volume is known, but projects haven't been selected, and I don't really know if this is going to be the full volume at the end. On the AI factory side, I considered only the hardware, not the support component, because I couldn't find any source that tell me what is exactly the support component in their side. And it only contains those systems where the procurement is out, and I can got the data from this TED platform. I took the AI factory antennas, which is only support, and I put it, however, on the same block as the AI factories, because they kind of belong together. But it's not a very large volume. It's something like 30 million or so, which in this volume is almost unnoticeable. And these are the HPC systems that are out there. Includes already Alice Recog, which is not yet installed, but the hardware has been allocated. So then I look into subcategories. So on the infrastructure side, around half of the money is AI factories and antennas nowadays. The HPC systems is around 45%, and then you have for quantum computers and for federation below 5% each category. So you know from the previous slide what I included in these AI factories and HPC. On the federation, I was a little bit, let's say flexible. I took the EuroFP, but also hyperconnectivity and the review platform, this kind of things you need for running the infrastructure. On the R&D side, the big blob here, around half of the funding is for hardware projects, or what I classified as hardware projects, and these are the ones that are here included. So it's EPI, is there, is the Net4X, that is interconnects, the pilot projects, and then the bit older ones that were in 2019, started in 2020, this also hardware related. On the applications, it contains the COEs, the Lighthouse, the transversals, and also benchmarks. And the call that has been closed in January is included here. So even if the projects haven't been allocated, I consider, let's assume the whole budget is being used, so it's allocated there. So it's around 30% on the application side. I was surprised to see, well, not surprised, but I was interested to look into how much goes into software, which is really quite little compared to the whole volume. Well, I put everything then together, so these are the overall categories: infrastructure, R&D, and skills. So that's how the whole, let's say, cake, putting the both cakes from the previous slide together, how this looks like. And that's what is included there. On the skills, you might be surprised, it's relatively large volume, but it's because most of it are the national competence centers that have quite some amount of money. So I also wanted to look how does this evolve over time. And what I found is that over time, this is 2020-21, so it's blocks of 2 years, the overall funding is growing, but it's mostly, or actually only growing on the infrastructure side. The research and development is more or less constant, and also the skills and cooperations is more or less constant. Remember, AI gigafactories are not here. So there is no, exactly. So the gap in between these two lines is likely to be much larger in about 1 year. And And then I did the same thing for the subcategories. So on the infrastructure, you see how the AI factories has grown on the last couple of years, and everything else goes down, more or less. On the R&D side, interesting is to see how this green line, which are the hardware projects, goes more or less on spikes. And the reason is that these projects tend to be very large, but they are only issued like every 4 or 5 years. So the first peak here is EPI and the pilot projects. The second peak is this RISC-V project and Net4EXA. The rest of the categories are more or less flat, a little bit increase here with the COEs seen for the call in January. So that was looking into the past. As I said, that's data which I cannot guarantee is 100% correct, but it gives you a trend on more or less where things are standing. And now the question is, how should this look like in the future, in post-exascale? What do we want to do? So for post-exascale, the situation in which we are now is that in 2027, the current multi-annual financial framework is ending. This means that a new period for EuroHPC will start that goes then from 28 to 2034. The governing board now needs to decide what they want to do for the next phase, for the next 7 years. What are the priorities? What are the structures? Will they stick to the same pillars? Will be the same topics or not? And they take input for this decision, of course, from their internal advisories on their national sites, but at European level from the advisory boards that wrong type. I told you before, we do this with the MASP, and also we created a document that we call the post-exascale vision. Plus, there is a new project running since April this year that is called SPE. That is a project running under Horizon Europe, generating roadmaps also for post-exascale. I have a couple of slides on this. So, what I show you in the next slide is what RIAC and Infra have recommended in this, or have documented in this post-exascale vision. We looked back into the exascale race and tried to analyze, okay, what went well, what maybe could be improved. What we think went very well is that world-leading HPC quantum computing AI infrastructure has been created. There is now a consistent legal framework for procurement and deployment activities, and there has been possible to launch larger R&D initiatives that were not possible before. What we think could be improved is that a better balance in the investments between R&D and infrastructure deployment should be reached. So you see from the plots before, 1/4 only is R&D, and most of the money goes in infrastructure deployment. We also would think that having more realistic benchmarks to measure success, and here the keyword is not only HPL, so it's not only what is the number from HPL on a system what makes it successful, but real application representative benchmarks. We think that could be improved in the technology update, so have a more clear path between the R&D initiatives and how they can be adopted in the deployments, and have a more consistent funding for application and software development. Last but not least, we believe that there could be also some reduction on the bureaucratic and management overhead for all those projects. So, summarizing in one slide what we think post-exascale should look like. So we think that there should be, or there will be, a convergence between HPC, quantum computing, and AI, even farther than we are today. We, as I said, would like to see real-life metrics, both on terms of time to solution, energy, efficiency, and so on. In terms, that's a very weird logo. I mean, I'm trying to visualize these things because if I put you text, maybe I put you to sleep. It's a bit silly, maybe, I don't know. These things should tell you that the density, compute density of the machines is so large that they need to now be water-cooled and be very density oriented. And also, waste heat reuse is becoming more important. On the technology side, optical networking will grow not only at the system-wide side, but also going down to the component that is might enable doing disaggregated architectures where the memory is pooled in the system, so not only at the node, but is accessible globally through a high-speed optical interconnect. The components, so the partitions of the computer will continue to be more and more heterogeneous, and we hope to see their adoption of more disruptive technologies. Mixed precision, hardware is much more stronger, or some of the hardware is stronger in low precision than in higher precision, so this will have to be adopted by applications. More AI services, something like core scientists that guide the scientists from the hypothesis down to the validation of their problems. And then in terms of cooperation, we think that more public-private partnership will be required, both for funding those things and also for joint services, joint accesses, and joint training and education initiatives. So one quick question is how actually HPC will evolve in the context of the growth of this whole AI, hyperscalers, and data centers. We have the feeling that this competition should move into a co-opetition, so that there is more cooperation between private and public computing entities. And we hope to see at European scale a very widely evolved, so federated infrastructure, where you have things like the gigafactories and the AI factories connected to HPC centers, connected to things like quantum computers, and also other exotic, the colorful dots should be more disruptive stuff, neuromorphic, whatever else, and down to the edge. So it's connecting the infrastructure, is having common standards and services, including data. That's something we have tried to highlight. The data has been out of Euro HPC until now. For the next phase, we hope that it's included because it's so tightly linked to the computer that it cannot be ignored. Should be joint training and support. Security procedures have to run across all this federation. There will be adoption of new computing paradigms and also unified programming paradigms to deal with all those heterogeneity. Now, where we are in technology development, so today we have a kind of two completely separate worlds. We have on the one hand side the technology development, and I put here this guy just creating, in this case, chips, but this could be valid for networks or anything else. And then completely separate process is the procurement and deployment on infrastructures that ends up to be just procuring technology coming from elsewhere. I prune US, but that's because that's the most common source, and the guy with the hat should be the one paying. Hopefully, there will be a more clear path in post-exascale for the adoption of technology, so that there is a clear path from development, always wrong, development into the deployment. And of course, we are not saying that everything will be only European on the machines, but at least a more healthy mix between both. On the software side, you are very well aware that we have applications somewhere sitting up there, and then we have a very heterogeneous hardware underneath. And the thing that makes this thing useful is all the software layers in between. So particularly compilers and libraries try to smooth out very much of these differences, but also programming models, abstraction layers, and so on. Taking into account the convergence of HPC, AI, and quantum computing that we foresee, we also think we need new software solutions. More low-level solutions abstracted from the high levels APIs for resource and energy optimization, programming models, including also AI copilots, and tools for mixed precision, and security across all the stack. So you might know this quite well-known comic diagram from XKCD, which shows you how very often the whole stack depends on a single component here, which according to the author is developed by a person in Nebraska, thanklessly maintaining it since 2003. So I put this in the context of software because I think in the context of software is very often the case. You have open access, open source software that is developed by somebody somewhere, but without really plan or long-term stability for this structure. On top comes the volatile funding agencies, funding decisions and political decisions that play with things, and that sometimes I was trying to put a dice, but I didn't find a way to block these things, so this guy should be playing Miller and take the thing out. I mean, this is stupid, I know. But what I like to see is that we have a long-term sustainable funding for open source software. When you see the diagrams I showed you before, we don't have this nowadays. A very clear case of that situation is the end of the ECP project in the US. Within 10 years, a very interesting, very good software development has been done, and suddenly things stopped, and it was not clear how to move forward. Same could happen in Europe, and I hope that Europe takes a more leading role in this context, having a more long-term plan, the same way as you have a long-term plan for the reinstallation of hardware infrastructures. We know we have to substitute machines every 5 or 6 years. The same happens with software. You have to have cycles of funding to support it on the system software and also on the application side. On the application side, you have typically hardware application developers that are trying to deal with things happening in the HPC or AI landscape. So, for example, GPUs coming up, you need to restructure your application, you need to rewrite it, some special purpose accelerators, and coming next is this AI reduced precision hardware where many algorithmic approaches might need to be adapted. And what we would like to see here as well is to give the application teams tools and support so that they can deal with this heterogeneity. The same applies for the software environment. They need all these interfaces or these high-level programming models to be long-term sustainable, that they can have the confidence they will be there in 10 or 20 years, because applications take that time to develop. Yeah, and I think that's the last part on the application side. So we observe that the AI hardware is not fitting with traditional simulation requirements, particularly the low precision problem. Legacy codes, however, still remain essential, and they will need to be sustained for the years to come. Data is very important and often overseen, so we need better integration of domain-specific data lakes, we need the computer-near data, and so far and so forth, and exploiting AI for code development, but also creating data sets that are available in AI-ready format. So here I believe that code design plays a role, so it's not just giving a kind of hardware component to an application development, do what you can with it, but you need to have interaction between hardware, software, and application developers so that the whole thing works. So, just to give you a comment on the last blocks of this Euro HPC context, so security and sovereignty, we recommend that there is a stronger collaboration between the hosting sites and the security working groups. There is a need for training and education on the security topic for operations and users, and to establish validation methods for AI. So can we trust what AI is giving to us? It's also a concern on security. On sovereignty, the supply chain need to make sure that we continue having access to the technology we need. And since we cannot do everything, decide what are the leadership areas, or the areas where we want to keep or achieve leadership, and make a priority on those. And last but not least, on skills and international cooperation, so recognize that this is also a long-term investment. So you invest on manpower that takes many years for training and education, and the job market is also changing. Adopting AI on education is important, not just ignore that it's there. There is this EU master for students. We think it would be valuable to have also a PhD school at European level. And create new career paths that are combining academia and industry. Not forget user support, of course, with the projects that are running or equivalent ones. And international, so attract international expertise and workforce, enhance cooperation with the international areas, so with areas like this one where it's already established, and then create or make really possible international R&D projects. So right now it is in theory possible, but it's always a problem to get the funding matching for both sides. We get from the European side for the European partners, but it's hard for the other side to get a matching funding, and this should be kind of cleared up front. With this, I'm done with the RIAC and infra post-exascale vision part, and I want to just spend a minute saying that there is also this SPE project that is standing for Strategy for Post-Exascale. It runs under Horizon Europe, and the role is to develop vision and roadmap for Europe in post-exascale. It's also aimed to develop a competitive, converged HPC quantum AI ecosystem and to enhance international collaboration, so we make sure that what we do in Europe makes sense in the global landscape. If you want to get involved here, the contact people are the coordinator, Yannick Bertou from INRIA, and Sai from ETB for HPC, which is leading the roadmap work package. And that's the plan they have. So they want to get input from the community. That's where you can play a role. And they have these groups of experts where they gather information to create policy papers, vision and roadmaps, and funding recommendations, give them that to the European Commission, and then hopefully get them ideas on how to better structure and formulate this for the next phase of EuroHPC. So that's it. What I wanted to give as a last message is that right now is when the future of Europe is in HPC is being shaped, and that you can contribute to different vehicles. You can do this through the getting in contact with the advisory boards of EuroHPC, through this SPE roadmap project, and also on the technology side, get involved in co-design initiatives. Thank you very much.
Thank you, Estela. We have time for some questions. Okay. Florian first.
Yeah, Estela, thank you very much for this brilliant presentation. I have a question. So in our work for the scientific and innovation case for computing in Europe, we did not look at the funding, but in the available computer resources for regular and extreme scale call, which we consider as the most relevant for scientific communities. And there we found that over the time, the available resources decreased. Also, again, with your same restrictions, only we could use public data, so the calls. Knowing that the overall resources with put into Jupiter in operation increased. So, and we did not yet considered the effect of the AI systems. So, do you have an opinion on this? So, knowing that on the one hand side, the funding is moved to extremely to AI, and the available compute resources for scientific research is decreasing?
Well, my opinion is that that's going to be difficult to deal with. It's hard to foresee what is going to be. So the idea of these AI factories and the gigafactories is to offer compute time to industry, right, to SMEs and also on. I don't have personally the experience nor the information to know whether all this is going to be taken up by the European industry and if it's all going to be required. I hope that also within this context there is possibilities for the scientific community to be part of the users of that infrastructures as well. But I really hope that one recognizes, as I think also your SRIDA says, and we also observe that applications, traditional applications, scientific and physics-based applications will still be important. So we still need resources for those. Where and how you get access to those, I don't know. But I don't think that we should put all the eggs on the basket of the AI, to be honest. Although adoption is important, right? But it's not only this. Yeah.
Thank you, Raymond, and then to Maria.
Yes, thank you, Estela. Sure. Yep. All right.
Raymond first.
No worries. I'll go first then. Estela, so thank you for the talk. So I was just thinking here, and what struck me was the decrease in the classical HPC systems. So obviously that's falling off, high precision becomes an issue. So what's the sustainability ideas from the RIAG, from EuroHPC there? Will there be new calls refunding those, or should we expect that the drop-off will just continue? And skills and cooperation, to me, actually is very small in this budget. I mean, you mentioned, okay, it seems large with NCC. NCC is mostly focusing also on industry uptake. So for science and actually making these systems work for science, also for this community, I consider that very, very small and much smaller than we would consider as a national level, where we would be more at, say, 10, 20, 30% of the total budget.
I do agree. What I meant is that I was surprised because my perception was that it's even smaller than this. So my perception was that I wouldn't see on the big blobs on the cheesecake there a specific part of the skills. I find it larger than I expect because thinking about skills, I was thinking about support, and I was thinking about things like Minerva, like Epicure and all that. and also training, like the EU Master and so on. The NCC is a different category of things, but it's in the same kind of context. And I agree, it's not the same kind of clientele. So, yeah, also their education, training, support is keeping, that's one of the recommendations. We need to keep investing on this. Is this the whole, I don't remember if you had another part of your question, sorry.
The other part was on the classic HPC, right?
Yeah.
And especially also, if we want to make the HTC side, so the high throughput computing that kind of could have similar needs as AI, but has more, let's say, high precision needs, and with the classical HPC dropping off, and there's no clear communicated pathway for sustaining those, how do we handle this, and how do we merge the communities?
I don't know. I mean, this is the problem of putting all the focus only on one thing at a given point in time. So I hope, I mean, the HPC systems that have been deployed 5-6 years ago, they need to be renewed. The way they are renewing it right now is adding an AI factory to this. But the kind of hardware you put there is normally not the same. So if you require high precision and so on, it's not going necessarily to be serving you in the same value. I hope this is recognized on the next funding phase. I don't know, cannot tell you. So we give advice. What is done with the advice is something else.
Okay, thank you.
It's out of our hands. Maria, I think.
Well, as I had a very similar question to Raymond, and I can't re-ask it, then let's try to turn it into a discussion. Yeah, we as a science are worried about the recent trends that we observe in how all the ecosystems, in fact, of infrastructures in Europe, but also outside, are shifting towards looking at AI, but also how to support industry. And we don't have the same amount of money. We can't influence that much where we are going. So clearly science is worried right now. Now, looking at your analysis of the EuroHPC trends, we are even now more worried because in the in the next couple of years, basically, we see that HPC goes down, AI factors shoot up, and this is bringing also shifts in terms of hardware choices that may not be useful to science that much. At the same time, you're also showing that the R&D is going down. So for emerging sciences like data-intensive science, in particular radio astronomy and energy physics, how can we influence or at least to try to advocate our needs towards infrastructures like EuroHPC?
Well, the normal channels you have is through the advisory boards, through this project that is being now put up. And if you have contacts to the governing board members themselves, of course, as well, you can discuss with them. I don't know any other channels than this. So speaking with the people you know in the decision-making positions. I agree with you. I just don't know how we've been on the advisory side repeating this again and again, how important it is to keep the scientific community support, the development, the research and development calls. I mean, you don't see too much there because you have still the peak of the DARE project and the Net4X that is rising the R&D side, but nothing has come out on hardware development also in the last 2 or 3 years. So it's tricky. And on the software side, it's disappeared almost completely. So I hope that when we repeat the same message again and again and again, at some point it will arrive. But I also understand the politicians have a lot of pressures from other directions. And one last comment one should say, to be fair, is that the problem with reduced precision hardware and with hardware moving towards AI is not only due to political reasons, it's due to the drive of the market. So you cannot compete with Microsoft or Meta or whoever it is that have the deepest pockets of the world and say, I want this hardware, you will build it like this. So they will not build different hardware for us.
Definitely aware about that.
So we have 2 options. And we think we have to do both in parallel. First is try to see how much of that hardware is really useful from the application side. So keep open and think, can I exploit something? Can I apply new methodologies, new algorithmic that allow me to do something? And the other is invest also more in technology that still supports the kind of features that the other applications also need. So at European level, maybe some smaller vendors can give, make designs that fit this community. Smaller vendors can have this niche market and use it as their target. Both things can be done. I don't know otherwise. There's some hand over there.
Sagar.
So I see a very nice discussion. And so Estela, I also wanted to explore a scenario where, as you said, that the hardware choice of the infrastructure buying capacity for public sector is getting squeezed because of the market conditions, and it's not a political choice, it's a market-driven phenomena. Why? I was thinking, if in your scenario where you say this percentage of investment should be gone into software development, application development, why can't we radically try to increase that or suggest that? Because maybe in a AI-driven market where hardware choices are more and more driven by that kind of technology choice, maybe we should focus on scientific applications and making them ready to work on this hardware to produce great science rather than having this science-specific hardware choices. So I just wanted to, maybe this is also a discussion on maybe a bit more radical to shift the proportion to more application readiness in the world where you will have hardware choices dominated by AI design.
Yes. I'm speaking here, I should say this, by the way, I'm speaking here in my own personal voice. I'm not representing anyone, not that I get in troubles then on. One thing, my personal opinion on why this is not possible is just because hardware is more sexy. Yes. So it's much easier for a politician to go and make a picture in front of a rack or many racks than it is in front of somebody coding. So it doesn't sell the same way.
But as you said, for example, if you could articulate and repeat this message, probably 50 years ago, I think investing in hardware would have been also politically risky. So I think for 50 years from now, maybe we should start articulating as a community a message on whatever the hardware choices evolve in the next 10, 20 years, maybe making massive investments into application software stack is the best investments that we can make to have long-term science vision come into reality. I think that could be the kind of message that we can bring out.
Yes, I agree, and yes, repeating the message doesn't harm. One concern with the hardware, why it is also somehow important, is this geopolitical situation, right? So will we have the access to the hardware we need all the time, or do we need to have some alternatives on the backside just in case? But nevertheless, the balance between both things is at the moment, it's a very big opening, it's a very, very big difference. We have been advocating and reminding in things like the ECP, there was half of the money for software, half of the money for hardware. I don't see, we've tried repeating, why not trying the same thing, or at least going in a similar direction, and it doesn't seem to be politically possible, or I don't know why. So one of the things is, well, what the main motivation, I think, from the creation of EuroHPC, and still many people see it as the main vehicle for infrastructure deployment and much less for anything else, unfortunately. The problem we have is that what we could do in research and development in the previous time in direct calls to European Commission or somewhere else has somewhat halfway disappeared because they said, oh, EuroHPC will take care of this. And somehow, at the end, it's falling in the cracks. It's neither done on one side nor done on the other. Repeat the message, I don't know, that's the only thing, maybe it ends up ending up at some point.
Yeah, so I wanted to go back a bit in the line of Maria Girone. So here we are like scientific communities mainly represented, like trying to express our needs and our gaps. And I mean, thanks for sharing all these overall pictures on the distribution of funding. So it's really interesting to see. And so one main question I have, it's like how could it be made more visual, like where the user communities
I made so many cartoons,
stand.
I can make it more visual than that.
So how to make more visual where the user communities stand? I mean the distribution of money, so we stand under the applications, the developments, but this gets diluted from this bottom-up approach, like from infrastructure-centric or software stack-centric vision, and probably like having a way to depict like where like the funding for the user communities is also distributed, so where we stand in the co-design that is always requested, where we stand in this piloting, where I think it would make easier as well for the scientific communities to raise our voice and to try to collaborate in this overall development.
For sure, I mean, you can get endless with this kind of analysis. This is very high level is what I've done, but you could get deep dive into how do you split this on the application side onto the different communities, and I personally just don't have the data to make a clear split between these things. I wish this kind of analysis could be done seriously, properly, and dedicated. I mean, I dedicated my vacations 2 weeks for this, but it's not, I cannot dedicate my full time on that. Yeah, but you're right. So visualizing the data, getting more insight out of the data maybe could be useful. Yeah. Andy had a question, but I think they are trying to finish the session.
Yeah, just very quickly. I wanted to comment on something else, not a question. So, in my opinion, what should not be forgotten is that science is the ground for future economy. Yeah? And this is an argument we can bring for the decision makers to take a decision now, not to leave science behind, yeah, when it comes to provision of compute. If we really need this high precision computing, and we can argue for that, then it's really mandatory to provide us with that to really create technology that can be transferred to industry in the future. And this is a benefit for European economy.
Yeah, I agree. So making more visual what are the outcomes of all the scientific side is on the economical side, on the societal side, how important it is that this is there and it supports the whole structure. Making things visible, I think, is the main challenge. Making them, the main message is visible to where they need to be visible.
Okay, I need to wrap up. Maybe I would have just one final comment and then we wrap up. So you made a very interesting study by analyzing the data on investments on EuroHPC. And so we see that EuroHPC and the factories, they have this kind of gravity, they attract lots of funding. We're not sure from where it's coming from, in the sense of where it's being removed from, or it's just new money increasing for infrastructures. How difficult do you think it would be to try to map, to identify what are the tenders at the national level that do national investment that are complementary to, like we have many national facilities supporting science. Are these funding these facilities preserved, or is they are suffering from money being redirected to? That would be interesting, but I don't know. That's probably, as you say, is a proper study. It could maybe
again, so this requires probably months of analysis if you want to do this at also national level. I did this because you always have like perceptions and feelings and impressions, but I wanted to have some data that I can really realize how the situation is. Doing this at national level, to me, the main challenge is to have all the sources put together. That's why I also didn't include all the European Commission side. My feeling is it's much lower than the budget on EuroHPC, but I also didn't have access to all the calls and all the initiatives that they have. Perception-wise, what I can say from my perception in the German context, that's where I'm embedded, is that because EuroHPC is there, projects and funding things that were done before at national level are not done anymore because they say, okay, we are already putting money on the co-funding of the EuroHPC side for example, software development. We don't need to do this on the national side anymore. Andy and Florian and other people can correct me, but that's my personal perception. That is falling out also on the national side because they rely on this being done now in EuroHPC. And if they don't do it because they put priorities on AI factories and other words, then it disappears somehow in the cracks, in between the cracks.
Yeah, we need to make sure that in the final version of the Spectrum documents, we sharpen very well these messages.
But I don't have numbers, that's the point. Okay.
Thank you very much. Thank again.
You.
Okay, now we go after the keynotes to the first technical contribution from the Spectrum project. We're going to understand and dive into the technical blueprint. And we have our speaker will be remote because of the disruption I've explained earlier. We have Jeff Wag from the Observatoire de Côte d'Azur. And he will give the presentation about the technical blueprint, and then we will have a panel discussion. And then we will break for lunch. Jeff, are you here? Can you try to speak and see if we can hear you? We do not yet hear you. No sound. So we should have Jeff soon. Hear the voice. We're going also to see him, or need to find the right plug to channel the audio. No, no sound.
Hi, can you hear me?
Yes, now yes.
Perfect. Okay, so that's all right? Okay, great. All right, so I cannot see the slides here, but I will go ahead. Okay, there. Thanks, everyone. So first off, apologies for not being there in person. I think as most of you are aware that there were some severe travel disruptions yesterday. But what I'm going to do is I'm going to summarize for you one of our two main deliverables for the Spectrum project. That is the technical blueprint for a European exascale compute and data continuum. So what I will do is present, and then we will transition directly into a panel discussion. We have 7 experts. Most of them are there in the room. And so we'll have some questions and answer with them. And then we'll have an opportunity for you in the audience to ask questions and add to the discussion. So first and foremost, I wanted to thank all the contributors. The main editors are listed here. But I really want to emphasize that this work was the efforts of the entire Spectrum Consortium with many inputs from around the high energy physics, radio astronomy, and infrastructure communities. Next slide, please. So this is where we are in the discussion today. So after lunch, you'll have the opportunity to hear from Sergio, and then at the end of the day, from Chiara and Valentin on the community of practice. Next slide, please. So as Sergio highlighted already this morning, we are really entering the big data era for both high energy physics and radio astronomy, the exascale era, if you will. where, for example, the high luminosity LHC is expected to generate an exabyte of new data per year over the next decade. So we're going to be dealing with these large volumes of data. For some experiments, these data are going to be coming in at high rates. And of course, these data are not all uniform. They're coming in at, they're very heterogeneous, and therefore we need to find ways to address these problems. Next slide, please. This is also the case for those of us working in radio astronomy. So compared to our optical colleagues, for example, the Rubin Observatory LSST is generating between 6 and 7 petabytes of data per year. LOFAR 2.0 by the end of this decade will be generating around 20 petabytes of data per year. And around the same time, the 2 SK Observatory telescopes in South Africa and Western Australia are expected to generate in excess of 250 petabytes of data per year. Now, those numbers are still uncertain, but it shows you how we will be entering the exascale era for radio astronomy in the decades ahead. Next slide, please. So this is one of the main objectives of Spectrum. What are the technical capabilities that are needed for a compute and data continuum to solve these exabyte scale data challenges? Next slide, please. To begin to address this, we established a community of practice, and you'll hear more about that later today from Chiara and Valentin. For those of you who aren't familiar, a community of practice is simply a group of people with a common interest in a technical domain. They're meeting regularly to collaborate and share information, improve their skills, and advance knowledge of the domain. Next slide, please. So we established our community of practice with these 6 working groups in the first year of the project. They cover all of the areas that you would expect would be important for a compute and data continuum, for example, data management and access, the environment, the software tools, and the facilities. Now, we currently have 64 members. Across the 6 working groups, these groups are still open to new members. We are meeting continuously on a monthly basis, having discussions as well as presentations from experts from our community. And we'll hear more about the sustainability of that community of practice from Chiara and Valentin later today. Next slide, please. So one of the first deliverables for the project was this community of practice report. Big thanks to Tommaso and Valentin for leading that effort. What we did was to survey the community. We surveyed the community both on the research side, high energy physics and radio astronomy, as well as our infrastructure providers, asking them questions about how they process their data, what are some of the main challenges, and what would they like to see in the future. So there was a lot of good insights that came from that that we've used for our final deliverables. We also worked very closely with our community of practice to write or publish our compendium of use cases. So what this is a list of science use cases describing both the scientific and the technical needs of a series of experiments or observing projects, focusing mostly on high energy physics and radio astronomy. Next slide, please. So these are the use cases we covered. The high energy physics cases cover all of the big experiments at CERN, as well as an AI-based particle flow reconstruction use case and one for large language models at CERN. On the radio astronomy side, we could have been a lot more exhaustive, but what we wanted to do here was focus on use cases that were specific to the data processing that we expect to take place in Europe. So in the case of the SK Observatory, much of the data processing is happening at the 2 sites in Perth and Cape Town. And what we have within Europe is this, or at least as part of this federated SK Regional Center Network, or SRC-Net. So we tried to be inclusive of the different flavors or varieties of experiments or data processing approaches that would be taking place here in Europe. We included the use case on an experiment studying the hydrogen gas during the early universe through the 21 centimeter line. We also had a use case studying the wide field surveys of star-forming galaxies at the continuum emission using SK Mid in South Africa. We had a similar use case for extragalactic surveys with the LOFAR telescope in the Northern Hemisphere, a use case on transients, and finally, a use case where artificial intelligence might be used to characterize gas-rich galaxies in a big spectral line cube observed with SK Mid. Now, even though the focus of Spectrum has been on the needs of the high energy physics and radio astronomy communities, in the end, we want our results and our recommendations to be more broadly applicable. So we have looked at other use cases We've looked at the Ligate project in chemistry. In meteorology, we've looked at a Mistral use case. And finally, one in neuroscience, focusing on e-brains. Next slide, please. So work package 5 did an excellent analysis of the existing landscape for infrastructures across Europe. They looked at the existing approaches, the services, as well as technical solutions and the policies for the Federation of Compute and Data Compute Infrastructures. From that, they were also able to derive some recommendations. And so we looked at how our scientific community are currently accessing their compute resources, and then from there, what might we like to see, and how might we be able to achieve that in the future with our colleagues in infrastructure going forward. And so these are the two deliverables here, which again fed into our main deliverables, the technical blueprint and the SRIDA. Next slide, please. So from our surveys of the community, as well as the landscape analysis and the use case analysis, where we looked at common challenges, common workflows, common compute and storage needs, we came up with this consolidated set of gaps and requirements. This is just a high-level view of that. For more details, please see the technical blueprint as is listed there. We had gaps across users, user access, workflows and software, some gaps in the area of data, as well as resources and federation. We also found some cross-cutting gaps on security, co-design, and workforce and sustainability, and this will come back a little later. Next slide, please. And so this is where the compute, the technical blueprints for this future compute and data continuum comes in. I want to emphasize again, these are some of the main contributors to this, but it was really the efforts of the broader community who provided us with their insights. Next slide, please. So the goals of the technical blueprints, the high-level requirements of this future compute and data continuum, or the key capabilities or what we should provide or what we'd like to see for the community in the future. We did this by integrating the scientific, technical, and then these policy requirements, focusing again initially on the high-energy physics and radio astronomy communities, as these are the communities which most imminently need access to exascale compute resources. We hope that we are providing some clear and actionable recommendations. And again, all of this has been built on input from the community, as well as our access, or at least our infrastructure survey. Next slide, please. So this slide just shows you some of the main contributors. I really want to thank Maria and Eric for leading the first draft of the technical blueprint, which was published in December and released through a community webinar. Some of the main writers are listed under the contributors, and then a big thanks to Tommaso, Raymond, and John for acting as our internal reviewers before submission, before the final submission. So that was released in December. We had great feedback from the community over the next 2 months or so. I think about 27 people from the community specifically commented on the technical blueprint. Following the experts event that Sergio mentioned early on, we also had 6 or 7 people actually contribute directly to the document from the community, and so big thanks to them. I know some of them are in the room there today. Next slide, please. So this is what the high-level view of the contents looks like. We start by describing some of the preliminary work. We want this document to be self-contained. We did a summary, a condensed summary of some of those initial deliverables. There was a big section on sustainability. Big thanks to Sean Mignot and his team for leading that. That was one of the sections I think that we had a lot of really good discussion during the experts face-to-face meeting on, and that was, as a result of that, that was one of the sections that improved a lot between the initial release and the final version. We then have a section showing you the compute and data continuum, as well as some recommended actions and technical activities. Next slide, please. So this is a high-level view of the capabilities that we think should be part of this future compute and data continuum. These are subdivided into 8 different categories with 32 different capabilities. And so these are divided into initially resource federation. I think we've already heard that that's going to be an important part of any future compute and data continuum. Monitoring and observability, security and trust. AI and machine learning came a lot from the community in terms of the input, and I think we'll have quite a bit of discussion on this during the panel discussion at the end of this presentation. We had some capabilities on orchestration and workflows, software distribution, and of course, no compute and data continuum would be complete without compute and data resources. Next slide, please. So what I want to do now is just spend a few minutes going through some of these recommended actions in a bit more detail. Underneath standardization of interfaces, it was felt that fragmented APIs and metadata models, as well as job submission interfaces, are currently hindering interoperability and cross-site workflows. And so what we're recommending there is a development of common interfaces and metadata provenance standards, ontology-driven APIs, portability layers aligned with your HPC Federation platform, and then finally interoperable workflows and orchestration interfaces. We had a lot of feedback on the need for infrastructure co-design. It was felt that scientific and infrastructure roadmaps are often developed independently, and so this can create mismatches between the deployed systems and real workflow requirements. So one way we might address that is to establish permanent co-design forums between high-energy physics, radio astronomy communities, as well as the infrastructure providers. We'd also encourage engaging EuroHPC as well as national centers early on in the procurement and architecture definition. We were just discussing this, but again, ensuring future systems support both AI, machine learning workloads, as well as scientific double precision computing. And finally, the need to validate infrastructure capabilities against representative production workflows. Next slide, please. Software portability in heterogeneous architectures. Scientific software must execute across CPUs, GPUs, and emerging accelerators while avoiding simultaneously vendor lock-in. So some of the actions that we recommend here would be to review key code bases for accelerator readiness. I know there's millions of lines of code in much of our scientific software, but this is something that we're recommending over several years. Funding pilot migrations using portable frameworks. Coming back to sustainability, which we'll talk about a little bit more at the end. Support energy-aware software engineering and optimization, as well as develop open tooling independent of specific hardware vendors. Under data management and network performance, exascale workflows require automated high throughput provenance, where data movements across federated infrastructures. So one way we might address that will be to run joint SRCnet WSCG HPC data challenges, standardize high throughput transfer interfaces, third-party transfer services, integrating automated data staging into workflows. And we had quite a bit of feedback from our community on the need to plan transient storage and network capacity based on evolving scientific requirements. Now, most of the, we're now entering the stage, at least in radio astronomy, where we're not able to keep our raw data for the long term. So finding ways to exploit the scientific value of that data early on in the data processing stages would be very valuable. Next slide, please. In terms of workflow adaptation optimization, it was felt that current workflow systems are fragmented and tightly coupled to site-specific schedulers and policies. So the recommendation there would be to develop standardized integration layers between workflow systems and HPC resource managers, enable end-to-end orchestration across federated sites, integrate provenance capture and resilience mechanisms, and then exposing external APIs to site schedulers to decouple orchestration from local batch systems. On security and AI, it was felt that fragmented authentication and authorization systems can limit the seamless cross-continuum access and automation. So one way to address that would be to adopt a federated AI framework aligned with, for example, ARC, BPA, and/or EduGame. Another recommendation could be to harmonize authorization policies across infrastructures or supports service identities and automated workflows. And even though in high-energy physics and radio astronomy, we're typically not dealing with personally identifiable information, we'd like to see the integration of GDPR-aware security controls for sensitive data sets. Next slide, please. As I mentioned already, we had a lot of feedback on the needs to integrate AI and machine learning. I think this is certainly the case in our scientific workflows, but we're seeing more and more interest in integrating AI into the operational aspects of our facilities. To do that, we need to integrate distributed AI services for training, inference, and model training. We'd like to ensure future HPC systems balance the AI accelerator acceleration with scientific double precision requirements. In terms of operations of our experiments and our facilities, identifying workflows suitable for AI optimization and automation. And I think we'll have a lot more discussion on this with the panel, but we'd like to recommend investing in training for scientific software engineers and domain researchers. So finally, in terms of long-term resource provisioning and operational sustainability, most of our experiments, and this is certainly the case for high energy physics and is becoming more so for radio astronomy, most of our experiments have a relatively long lifespan, going over several years of the lifetime of a facility. And so we'd like to ensure that the compute resources are also available over these similarly long time periods. So what we're recommending here is to adopt multi-year allocation and operational planning models, maybe 3 to 5 years. We want to see the support for fair software data preservation and reuse, investing in long-term resource sustainability for research, software, and data engineering, and finally aligning infrastructure evolution with European digital sovereignty and sustainability objectives. Next slide, please. So now just as a final set of recommendations, I mentioned before that sustainability was one of the sections that really improved a lot from the first release of the document to the final version, and a big thanks to the experts who contributed to this. It was felt that sustainability should be an underpinning foundation, which may or may not be offered right now by EuroHPC, and something we need in the future. So we're suggesting or recommending sustainability should be a foundation as part of the design process, integrating sustainability into the infrastructure planning, procurement, operation, and end-of-life management. We also suggest adopting life cycle assessment, energy monitoring, and sustainability metrics as standard practice. I know that in radio astronomy, our users, especially our younger users, are more and more interested in knowing what the carbon footprint is of their workflows, and so we need to have ways of informing them of this. And finally, having efficient and federated infrastructures to promote shared federated services, common standards to reduce duplication and improve resource utilization. We also suggest optimizing software workflows and heterogeneous compute environments to minimize energy consumption and unnecessary data movement. So next slide, please. So tying everything together, this is just a high-level system view of how these recommendations would fit into the capabilities that I showed you earlier. So again, at the foundational layer, sustainability is a core design principle. Built on that, your federated infrastructure layer, supporting the hardware and infrastructure foundations for your compute and data continuum. At the high level, having infrastructure co-designed by our research community as well as our infrastructure teams. And so on that note, just going on to the next slide, what I'd like to do next is transition to the panel discussion. We have 7 experts from the community who will be joining us today to answer some questions. These are shown here. So to begin, I think he's online, Fabio Affinito of Cineca, who'll be talking to us as a representative of the National Large-Scale Computing community. We have Tommaso Boccali from CERN and INFN, who'll be talking to us on behalf of the High Luminosity LHC and WLCG Group. We have Louise Chisholm of the University College London, also a co-lead for the United Kingdom SK Regional Centre Network. John Swinbank from Astron, who's going to be speaking to us as a representative of LOFAR as well as the SRC Net. Andreas Linterman of SZJ, who's going to be also representing us or speaking to us today as a representative of the National Large-Scale Computing landscape. Andrea Manzi from EGI Foundation, who'll be speaking on behalf of the HTC Cloud Federation group. And finally, Maria Hirone of CERN Open Lab, who'll be talking to us about HPC integration in high energy physics.
Yeah. Yes, now it's impossible to pick one recommendation over another, but it's good because that gives me the opportunity to keep a common ground among all the recommendations. That is, according to my vision, the idea of bringing back the scientific community under the spotlight, which is something which is today already called a couple of times. In particular, it was highlighted by Estela. But it's important because, for example, keeping one thing which is, I think, very relevant, like the evolution of the infrastructure. I think that the co-design is something that should more involve the scientific community. So the infrastructure has been driven so far by LIMPAC, so in order to reach the exaflop and now going beyond the exaflop, but it is still serving the needs of the scientific communities. The data and compute continuum is something which is took into consideration when designing a new infrastructure. So I think this document, the technical blueprint, is very important because it brings up this kind of needs, and we should be, or the community should be more working to advocate for that, because my impression is that so far EuroHPC or in general funding agency is not very putting the needed attention on that. And another, but again, I'm repeating something which you already know. For example, the key cornerstone of all the software application infrastructure is the fact that we are missing some very important foundation, and still this is a place in which funding are not coming, because much of the money now are going on AI, which is much more attracting also the attention of the media, but most of the important results are coming also from typical HPC or HTC workloads, but this is something that are more or less underestimated in this moment.
Very much, Fabio. Okay, so that was the trickiest, most impossible to answer questions that we had for you. Many entry points into realizing the continuum. People, talent, training has been one of the recurring themes that we've addressed this morning, and that's the next topic for this panel. I will display the question for the room. And the first question, we're going to enter into a shorter answer to accelerate a bit. The first one was very tricky, so we let time to answer. And the first question is for you, Louise. From your experience with SRCNet, what do you see as the main challenges, name two, let's say, in recruiting and retaining the right technology talent?
So I think, just briefly, I think that it's the digital research technical professions and the challenge is that people have short-term contracts and having permanent positions, and that funding challenge. Having the work to be valued and recognised as equal to the research academic communities and institutes. There might not be career pathways, promotion pathways for people on technical professional contracts, there are for academic contracts. And so having that recognising, valuing sort of software outputs and data outputs, as well as academic papers, and having that visibility of the career pathways being possible, so people can see that there is a career pathway for them. They're not coming in at a junior level and there's no way forwards, and having those job descriptions from entry level to the equivalent of professor level, and ensuring there's skills and training opportunities as well.
Sure. John, going to be the same question for you, but from LOFAR perspective, do you see the same challenges as Louise?
Yeah, so I think much of what Louise said resonates with me. So the couple of things that I wanted to draw the attention to. The first thing is simply, I won't mention it for long because in some sense it's obvious and it's unavoidable, but financially we just can't keep up with the big tech industry. So I mean, we need, in the regimes in which we are now beginning to work, we need the top tier technical talent, and we can't compete with big tech in terms of hiring them most of the time. But it's really interesting. We've seen in the last year or so, because of changes in the tech environment, hiring for us has become much easier. Still a challenge, but much easier than it was. The second thing I wanted to draw your attention to is also, just as Louise mentioned, the issue of career pathways. It's been great that over the last, say, decade, the work like research software engineering or data stewards have become recognized professions that we're able to hire into, but we still don't have great answers to where those people go in their future careers. There's relatively few really senior individual contributor engineering positions, and certainly in the university environment that we work closely with, many of those are hired at the kind of postdoc level, but then there's nowhere for them to go after that. So after a few years, they bounce out and go back into industry. And then finally, the one thing that I think maybe Louise didn't touch on so much, but that I think we've really seen as a struggle at Astron, is partly because we have huge ambition, but historical, across the radio astronomy community, underinvestment in our data infrastructures. We actually have a lot of grunt work just to keep things up and running. There's a whole lot of technical debt, of legacy systems, of old pieces of infrastructure that we can't let die. And putting our best and brightest young technical talent to work on that, they pretty soon wash out and realize they could do something more exciting elsewhere, and so they want to move on. And I think that's really disappointing when, in principle, I mean, solving the mysteries of the cosmos should be the most exciting opportunity we can offer them, and then it ends up being a disappointment.
Thank you very much, John. Thank you, Louise. We have seen you've covered main challenges, and Fabio, we wanted to hear from you maybe more on the solution side. So based on Chineka's experience, what do you see as the most effective solutions for recruiting and retaining the talent, passion maybe?
Most efficient should be to offer high salaries, which is not the one that is actually in function. Yeah. But the point is that it's still difficult also for us to get the right solution, because it's a narrow intersection what we need between the computer scientists and the people that have actually some background in scientific research. And also because now we are dealing with the fact that a lot of people are attracted by AI in industries that may offer higher salaries than us. But there is also another thing which I think that we could work on, and this is something which is in the British world is more consolidated, like the figure of research software engineer. Which is something that could offer to people the opportunity to have an identity that we are still missing. And probably going in that direction could be something that could work in order to identify the job role that is something that we are looking for.
Thank you very much, Fabio. And speaking of role, that's maybe the last question about the talent and people. If we look ahead at the next decade, let's say we want to implement the dream world that Tommaso have. Louise, what do you see as the most critical roles in the data space that we're going to need?
So in the next decade, thinking that at that point we're now used to using exascale levels of data, and we're having a heterogeneous compute environment. And so I think this is going to change the way of working for researchers and for the research technical professionals. And it's going to be looking at, I think, how the different roles all work together. So it's not one role. It's the ability to work across the different roles, having across between people doing research software engineering, looking at data stewards, making sure there's data linkage between different data sets, and making sure that there's the infrastructure to support all the different heterogeneous so architectures out there are there, and there's the expertise to be able to talk and do that co-design and work out with the research software engineers and data stewards what works best, as well as the community support and activities and training to enable that community aspect. So I don't think it's one role, but I think it's what the difference will be, how they all work collectively together and have new ways of working. We have the new these career pathways that are emerging, and there's a lot of work doing to sort of help promote these new professions, but it's having all of that working together and people working, perhaps coordinating between them as a sort of as a linkage role as well between these different professions, and being able to translate between domain and the technical aspects to help coordinate all of those bits to harness the insights that the data provides.
Actually, very interesting, because engagement and collaboration seems to be one of the key points in implementing this vision for the future. And interestingly enough, transition for the next question for you, Andrea. So we know that scientific communities are definitely key stakeholders in the data processing ecosystem. And we just spoke about that. How do we manage, how do we engage them early in defining the requirements for the future compute and data continuum?
Yeah, of course, we had the discussion also before during the keynote, after the keynote about this, in particular for HPC. I want to mention what was presented also by Jeff. So this community of practice that has been developed by Spectrum. So where there are experts in multidisciplinary domains, and where discussions can happen at the level of requirements for their computing and data challenges. And basically having this community of practice, keeping and maintaining this community of practice like the one for Spectrum could help defining the requirements, which then we need to discuss at the level of the different infrastructure. Like it was mentioned before, the advisory boards for EuroHPC, where of course those requirements that are discussed at the level of community of practice could be brought and for their at least for the discussion and for possibly driving the future procurements or future systems. So this is a possible way.
And John, from your perspective, is it the same? So this community of practice could be one of the key aspects to engage early on the scientists in defining the continuum and the data pipelines?
So I think to an extent that can be helpful, but the point I wanted to make actually was from, I think, the radio astronomy perspective, at least in my experience, this is not a question that we've really yet found a compelling answer to. I think we've got a bunch of ideas, but getting scientists involved early and getting them really contributing is hard. I think one of the things that I've learned from experience with multiple telescopes is part of the thing is just to be open and transparent and early in what you're doing, even if you're doing the wrong thing. It's really hard for a scientist who fundamentally has to think about their career and where their next paper is coming from and so on, to sit down and work through a requirements document or even join a community of practice meeting. But as soon as you give them some data and say, hey, here's some data, we're thinking about processing it this way, then immediately, first of all, they can get a publication out of it if they can show they can do it better than you, and they can show how clever they are if they can show they can do it better than you, and they can head off the idea that your instrument is not going to be as useful as it could be if they can show they can process the data. So I think what I really want to push for is getting data into the hands of astronomers and scientists as early as possible and being really open in how we collaborate with them. I think there's one other part of this that relates maybe to some of the discussion we already had on the workforce development, that I think much of the science community, certainly in the radio astronomy world, is still, for sensible reasons, based around universities and on that more traditional academic career path. But we do have opportunities for things like instrument scientists and observatory scientists who can bring that scientific knowledge and be on a different career track where they're not so directly motivated by where the next paper comes from. And I think bringing them more and more into the core business of what we're doing in terms of actually making our telescopes work is really essential.
Thank you, John. Moving on with collaboration, Tommaso and Maria, we have the chance to have you and so to ask you questions about the best practices and what has been done at CERN level, and therefore, so distribute the parole among you. So we know that CERN and WLCG have led to several technical developments for the community at large, including WWW. So what approaches to collaboration at large and team organization do you think can be the most important to foster innovation within the technical teams?
Do I start? Yeah. So more specifically about the WCG, please don't assume that everything we did was right. So we survived, so it's already a good, a positive thing, but it's not that it was perfect at all moments. So clearly in this kind of endeavors, you have, before you are given money, you have to prove that you are going to be able to do physics in our case. So this needs a top-down approach which presents the computing model, the resources that you will need, and then, fine, you get approved. You look 20 years later and you basically did nothing of what you had in the initial document. And this is, I think, a good thing, it's not a bad thing, because at some point you need to believe and be open to the bottom-up approach. We have had thousands of young, bright undergraduate students, graduate students, and whatever. Estela was speaking about the fantastic guy in Nebraska. I think we had a few of them. We basically changed the way we were assuming to do things. This clearly is not just going in the direction, okay, our computing is better, you get more physics, you get more paper. So never really underestimate the power of people who are interested in a subject, and maybe they are not computer scientists, but they understand that they need a new thing which is not existing in order to publish, as John was saying. So this is a very powerful thing. The second thing which happened in WCG, this was not from the start, but it happened gradually, and I think it's a moral obligation, is that everything we do is open source. Open source, as open as you can think. Most of our stuff is Apache 2. We have some things which are GPL3, but okay, this is the ballpark. Again, we are paid by public money. This is very important. It's also very important that our solutions, clearly an industry will not grab the code to find the Higgs boson. They don't need this. But what we do in the end is not so different from what an industry has to do. In the end, data is data. Instead of high-energy physics data, you can do the same things on other stuff. So clearly, this has been a big boost and also a visibility boost of our activity. Other experiments, other initiatives are taking what we do. You quoted WWW. It was not WCG, clearly. This comes from before this. But this is a good use of public money to me. You have to develop something for a specific use case, then it becomes public. I don't know where we would be if it was made under royalties or things like this. Probably something else would have popped up. And the last thing I think I learned in the last 20 years is that there are technology enablers which are really fantastic. Probably networking has been the best one up to now. As soon as you deploy a large bandwidth, low latency networking between centers, people will find use cases and solutions which were not dreamed upon. So now we have this hyperconnectivity of EuroSPC. We have GEANT, which has been working very well. I think we are in a good position, but clearly investing in networking makes technical solutions, future technical solutions, much easier.
Maya, if you want to add something?
Yeah, maybe I can add more on the SEM perspective. So, CERN's core mission is clearly science. At the same time, we've been leading innovations in many areas, physics, particle accelerators, computing. So the known, the World Wide Web, of course, but was born to respond to a necessity. And this is probably what in an environment or in an ecosystem like CERN drives innovation. So when you have a problem that you need to solve, where many different teams can contribute, this is probably where innovation can be fostered and supported. So the problem was to share information, and this became then a worldwide solution for how to share information at any level. WCG at its start was also quite innovative because it was the largest federation of computing infrastructures that people could be imagining, but was responding to the fact that we had many scientists around the world that needed to access data. So how did we provide this? Was with the distributed infrastructure, because it was the most efficient way and to involve teams also. So I would say that innovation, from my view, can be fostered by making sure that teams are working in multidisciplinary environments. This is really key. So putting together domain scientists with infrastructure experts, but also with operations guys, people that really know what needs to be done in order to do the day-to-day, is going to foster innovation. Mm-hmm. And probably another important point is that when you want to innovate, you need to keep in mind that you want to build something that is going to be for production. So do not stop at the level of first concepts and early demonstrators, but also try to look how innovative ideas can scale out to production environments, because this is a way in which actually an environment like CERN has been working and has been providing these big ideas in terms of computing.
Thanks a lot. I have the feeling that it joins with what Liz and John was saying about transdisciplinarity, having different rules working together, opening the information and so on and so forth. So that was a cool insight. And last one from collaboration, you spoken, Maria, about the Federation of WSCG. So that's more than 170 sites. That's good experience that we can learn from at CERN level, especially for other networks building on now. So what would you recommend, I don't know, one big thing to sustain long-term collaboration across that kind of federation?
Okay, let me maybe rephrase the question in a more comfortable way. Like, what could we do today if we had to restart from scratch WCG? Which is a similar problem, but okay, it's not exactly the same. So clearly, times are completely different. When the WCG, so the Computing for CERN experiment, was designed, it was the late 90s. Just to give you an idea, Amazon AWS was born in 2006, I think. Microsoft Azure was 2008, 2010. So clearly, as Maria was saying, CERN has a physics goal. If something is in the line between you and the physics goal, you have to solve it. And in this case, it was how the hell we compute at this scale the thing. And so the design of WCG happened, and you had to start from scratch. The 4 experiments maybe went different roads, then maybe later they went together again. So it has been a complex endeavor. Clearly, if you restart today, you live in a completely different environment. So we have heard from the first keynote that there are big infrastructures in Europe like the EOSC, the EuroHPC, all the push for AI. So probably today is not the day to reinvent the wheel, or at least not to reinvent too many wheels, which we were forced to do because they were not there. So clearly, if I had to restart today, I would try at first to see what is available on the scientific, but not only scientific landscape in Europe, and not only Europe, because all these things are not at continental level, but again, we are speaking about Europe. And as we saw in many cases, and the WCG is trying to attract associate members, not directly from CERN, but also from other nearby sciences. The problems are not so different if you look them from a correct point of view. Clearly, one thing is looking up in the sky, one thing is looking into a tube underground, but in the end, you get lots of data, you have to process them, you have to have a digital twin of them, you have to analyze data, you have to distribute data and make it available to scientists. So I wouldn't say that all the solutions are there, but there are attempts of solutions in all the directions. So one could try and see what is available, do some mistakes, going the wrong road, but then trying to get back and see what you can do. In a sense, also WCG is changing into this direction. As I was saying, trying to collaborate with other sciences is mostly for our own interest. We are not really so nice that we want to solve other problems. If you share a tool and the solution with another science, you can hope that there will be help in sustaining this also from their point of view. So our things, our computing models and tools are becoming so complex and so big that we definitely need more help. And more help and more ideas, because another science can have a bright idea which was not coming from us, and then we are happy to incorporate. So the answer was to a slightly different question, but I think the direction is roughly the same.
So expanding collaboration with other communities. We need to speak, but quickly about AI, because I want to also take some questions from the room. But we need to talk about AI. Sorry about that. Thomas, yes, was saying bring the network and the use cases will go. And if we bring the compute and the data, will the use cases on AI go? Andreas, we want to have your perspective on that. So we know that AI models training requires a lot of resources, HPC, scale resources. And we're going to have the AI factories. Some of them already are there. What do you see as the best use cases for an exascale level compute and data continuum?
We still have a little bit of time, right? So, first of all, I would like to second what Maria said. Very important, interdisciplinarity. Yeah, and you mentioned that with humans, let's say. And I want to take this from a little bit of a different perspective. And I want to give an example because we had 2 weeks ago a meeting of the Joint Laboratory for Extreme Scale Computing. That's a club of the biggest HPC centers worldwide. And we had people from Japan over and from the US, from Argonne National Lab and from NCSA, from the Recon BSC people. And very interestingly, and we saw this already appearing last year, is the approach of agentic AI for science. So this is not domain specific, but this is going towards the direction how can an agent or a system of agents replace maybe at a certain point a scientist. And this goes over hypothesis generation, over validation and testing and running simulations and analyzing the results, and maybe then upon that fine-tuning the hypothesis and choosing another research direction. And this is something that we can do with exascale, I believe, of course, if we look again at what I mentioned before, where we have the inference part and agents being deployed on cloud services, we need this federated infrastructure where the agents have access to all these kind of different data, to all these kind of different methods. So there need to be interfaces to, let's say, MCP interfaces to different tools, and these tools can be simulations to the data that can be streaming data that comes from high energy physics or from astronomy. But this is broad, could be broad across different disciplines. And looking at the next steps. At the moment, at least, so this is still a little bit in the future, but they were already talking about this. They are engaging in that, and I think from the European perspective, we really need to catch up with that. But the next step here in the European level, I believe, is for the AI factors is the attachment of the data labs to them, where we have really attachment, domain-specific for different communities, a collection of tools, compute infrastructures, then a definition of workflows and orchestration that the people can, in the end, solve their problems. But this is not everything, because going back to this interdisciplinarity is with these AI agents, there will be specific agents that are trained on one domain, and they will talk to each other, and they will come up with interdisciplinary solutions way faster than, way faster than we will do.
I think we follow directly with for you, Andres, as well. What questions should be considered?
So
adopting that kind of AI solutions.
So one of the issues with that is, of course, if you look at the validation. So hypothesis generation, testing, validation. So at one point, at first, of course, they will rely on validation methods that the humans invented, but they will come up with their own validation methods. But then, of course, how can we be sure if these validations are correct? So they could hallucinate in the whole pipeline, let's say, and go into a direction that is unforeseeable for us. So, and we, because in the vision from the RCC, from the Japanese people and the US people, it's really one entry point only anymore for the humans.
Yeah, and this is a critical aspect. Yeah, so we need to stay in control of what's going on and understand what's going on. Yeah, and here specifically we can then go back to the skills. Yeah, so because nowadays, looking at the young people, they use ChatGPT and everything. Yeah, they just push a button and they get the answer delivered, but they don't know how things work and they just believe it. Yeah, and there could be the fear that scientists would also believe what the AI agents tell them. Yeah, and without the skilled people to connect to that, what's really going on, we have a problem with that. On top of that, it's also energy awareness, of course. Yeah, so using a lot of tokens we have seen. Yeah, and they will just consume huge amounts for training and also for inference in the future. And this is something we have to take care of.
Thank you very much, Andreas. And to follow up, I will go to you, Fabio, with kind of a. We write that in advance, but I think it's quite following up what Andreas was developing. Do you believe that the growing enthusiasm around AI and machine learning for data center operation is justified?
It's a major effort to be 100% honest about that question. But yes, I will try to do my best. No, honestly and seriously speaking, I think that we should distinguish the hype from the enthusiasm. Because we cannot deny that now AI, but I would prefer to focus on machine learning as an important role in most of the workloads that the HPC center are called to deal with. And I think that it is important to work with a good mix of AI, classical, let's say, HPC, and now also quantum computing. But as with all the kind of recipe in, also when cooking, you should have a good choice of the proportion. So we should avoid to oversize the AI part or the quantum part and keeping the good proportion to obtain the good mix that we want to have, both in designing the new infrastructure, but also when it's about funding projects or when accepting workloads and projects.
Yeah, and actually I think it joins what you said, Estela, about having also funding and resources for non-AI things. Moving on. We talked about collaboration, we talked about big tech, and when it comes to AI, then what is at stake? How do we see the collaboration with industry?
Yeah, it's a bit of a difficult question because actually things are moving very, very fast. And what Andy was saying is a demonstration of how fast, even 2 weeks ago, discussions around the potential of agentic AI, but also industry investments are ongoing. Now, one thing that we clearly have to admit is that science moves at a pace that is not the one of industry, because we don't have the capital that industry has had, and the investments on AI even in 2026 have been probably would be allowing CERN to build the future CERN collider a number of times during, like every few weeks, because investments are simply order of magnitudes bigger. So how do we cope with this? We don't know yet. Are we going to work together? Are we going to diverge? Is a question that we don't know how to answer. But we also know that science moves at the different principles, not getting results as fast as we can, but actually getting reliable results. Validation is very important. To be in a trusted environment is also very important. So this is something that we need to keep in mind, and we are hoping that industry can help us in this journey. And I would say that in an ideal world, in this dream world that we were talking about earlier, it would be very nice that the industry would be, funding and helping science to develop concepts that may be useful for everyone in the future. So that's something that we are hoping to get, and CERN probably is also working in this direction of getting funding also from large industries. Industry has been always helping science, so endeavors like CERN Open Lab, I think, have demonstrated that over the last 25 years we have been co-developing solutions together, and that's definitely important. How this is going to evolve in the next 3 years, I don't know. It's something that I can't tell you. It is a very rapidly changing landscape, and my thoughts about how we are going to cooperate together 6 months ago are not going to be those that I would be answering to you today. So I'm just hoping that eventually we will converge, but that also the infrastructures of Europe will respect what science needs. And this is something that we were expressing as a worry in the discussion earlier on.
Yeah. So, yeah, different pace. We are looking for the next decade, but we don't know what's going to be there in 6 months with the industry. And to finish with, we wanted to have a question on storage, because storage is a critical capability in the future exascale compute and data continuum. And Andrea, what storage innovations do you think are still missing? Let's give 2 because we are already out of schedule.
Yeah, so I have not storage innovation, but enhancements at the level of storage federation and also at the level of the single site. So for sure we need, for at the level of the storage federation, that is part of the data continuum that we envisaged, common interface for storage, data access and transfer. This is something that for sure is needed. You don't have, so you will need to have ad hoc integration of each new sites when there is like a possibility to integrate a different computing center. And then at the level of the single computing center, level of the single storage infrastructures, exploit more the storage steering. So having, so for instance now, there is already like, different quality of service for tape and disk, but, there will be like, for sure, like in the future, different storage technologies, and have like efficiently exploiting, the different type of storage steering based on the quality of services, based on data access, based on data popularity. This is something that I think will be needed.
Thank you very much, Andrea. We are 6 minutes out of schedule. Sergio, Gwen, do we take 1 or 2 questions from the room, or because the timing for the lunch is a bit? Okay, okay. So we're going to take 1, 2, 3 maybe questions from the room if you have some. Amel, you're about to raise your hand. Mike.
This one? Okay, perfect. So I have a question on...
Mike again.
Oh.
When it's red, yeah, just pick.
Good. All right, now it's working. So regarding your vision of agentic AI for science, so I try to play a bit with this agentic AI. And for me, one of the main points is like the actually economic point of view with the tokens, because you actually need to use these models which are somewhere in the US, and you have to pay to use them. So what do you think? How should we take that into account, like the researchers?
Okay, I did not know that this turns off when this turns on. Sorry. Okay, so generally, NVIDIA Jensen, yeah, this guy, he was, I read a news article just yesterday or 2 days ago, yeah, and he was talking about the strategy from NVIDIA's side, yeah, and everything is about earning money, yeah, so tokens, yeah, it's all about that, and that everybody in the world should use the agents and ChatGPT, etc., and spend most of the tokens on that, yeah, and of course they are providing the hardware for that. The question is, of course, I understand that, yeah, it's about European sovereignty, yeah, because the models, they are served in the US, they're developed by the US, and all the money goes to the US, yeah. So, in my opinion, it's very hard for us in the European landscape to keep up with that and develop models that are equally good. Yeah, but there needs to be more investment in that if we really want to keep up with that, because we have the machines to do these kind of trainings at scale. Yeah, I mean, that's a similar thing that Marie was talking about. If you look at the industry, you see that there's so much things going on, and they invest so much money. There's so much money flow in that, yeah, and we simply don't have that on the scientific side, yeah. But if our expertise is in really in model development and in quantum computing, actually also here in Europe, yeah, if we really push that further and especially inspire the transfer of knowledge from science to industry, then maybe in the future we will be able to keep up with that. Maybe, yeah.
Another reaction from the panel on this one, or John?
So maybe just briefly, I think one of the things that I think there's an opportunity still that Europe could exploit, and in fact I think that Mistral, the French company, is trying to exploit, is to look at what we can do with models that aren't simply competing with the likes of OpenAI or Anthropic on pure size. So thinking about how we deploy smaller models, but that are targeted to particular use cases, that are running on edge devices and so on. I think this is an area where, as I say, Mistral has already expressed an interest and ambition in that direction. I think that there's a real opportunity there, because at some point the super models that the big American companies are developing, you simply run out of infrastructure. There's only maybe another generation or two of scaling they can do. And thinking about then how we are smarter but smaller is, I think, a really interesting area of research for the future.
Thank you, John. Last question from the room. Philippe?
Hello. So we just issue our scientific and innovation case at press. From your perspective, what would be a use case that demonstrate the better leverage between your infrastructure? This is always difficult to get funding for high science, for so that sort of things. And so if we want to have some funding for the spectrum from the continuum of computing, what would be one key example that show a very huge leverage between our research infrastructure?
Maybe. I think that you probably understood that I don't like AI too much by now, but I think there is a small advantage that we have there, because usually the supercomputing centers has always been quite close, in the sense that, okay, give me your 1,000 lines of code, I will run them for 2 months and I will get a number. Now, if they have to be repurposed for AI, which I think is a request from the funders, at some point they will have to handle data. And they will have to handle local data, but also remote data, heterogeneous data, problematic data. And the approach in which you simply bring everything to the site and then you do AI, I don't think is going to scale, because you are late by definition. So I think we can sell our experience in handling large amounts of data. We have exabytes of data, as Jeff was saying. And on top of this, maybe it's not so interesting as data for the industry, but is well understood data. So if you need to train on something, we have very precise simulations, digital twins of what we have. So in principle, we have the truth, if you want, to compare with. So we could be used as a very intensive use case in which you want to show a geographical level training on many petabytes of data of different nature, trained on different facilities. This, I think, I never saw such a use case available around. Then industry and whatever will decide if it is worth or not. But in principle, we have the capability to go into this direction.
Thank you so much, Tommaso. I think we will close here the panel. I want to have a big applause and thank you to the panelists of today, and as well as Jeff. And Sergio, if you want to say a few words about the lunch and what's coming next.
Yes, now we will have a lunch. It will be served in the room next door, where we had a coffee break earlier. And we will need to short by 10 minutes, so it will be 40 minutes lunch. You can get opportunity to refresh, have some good food, and also talk to each other. And then we will resume for the second part of the meeting. Thank you very much for your contributions. Thank you. Yeah, you can leave everything here. We are next door, so.
Sergio, sorry, at what time we are exactly restarting?
A quick highlight on the roadmap investment areas, which would take more time for dive into, but okay, we will find all the details in the document. And this is structured similarly to the previous session. There will be first a presentation, then we will have a panel discussion. And that's the next block. And then the last part of the day will be more with a presentation on how the bottom-up collaboration between these communities and infrastructure providers could continue, and some closing remarks. So we saw the details of the technical blueprint, and we need also the other side, say more the overarching, the vision, the goals, and the strategic directions, and what are the priorities that also tackle not only technical aspects, but also non-technical aspects that are essential for this compute and data continuum to exist and function. In this slide, we attempt to describe a bit of the ecosystem of the players that are involved. And that was also one of the questions we got from the various consultations, was to clarify the overall ecosystem of players. That's our current attempt. So I will describe briefly. So at the bottom, we have the scientific instruments. So basically the reason for the project to exist. There are large-scale experiments producing scientific data, the large-scale scientific data we need to deal with digital infrastructures. And then that's also the scientific instruments. Then the level 1, okay, we cannot see now. The level 1 is we already moved to the digital part. So the level 1 is the individual sites that exist. And no, I think they did from the back. Now the presentation was the correct one before. But I don't know why we are now to the panel. Oh, they are here. Yeah, it's more from the back. The presentation from before was the good one. Yes. Okay. Okay, that's a good one. And the level 1 is the sites. So I mean the data centers that are either providing pledged dedicated capacity to communities. They can be owned by the scientific institutions anyway, they're dedicated to the science. Or there could be horizontal infrastructures that serve this specific science, but also other communities. And normally they have also some shared capabilities. So you may have, for instance, a national site providing horizontal capabilities for many sciences, but also having pledged resources for these specific thematic disciplines. Going one level up, we have described let's say, more the operational federation, so aggregation of the different resources, computing, storage, and data, and so on. So we see that already the 3 scientific instruments represented in spectrum, they have their own federation structures. We have WSCG for LHC, SRCnet for SKA, and LOFAR LTA for the LOFAR telescope. And on the horizontal side, okay, we see initiative like the IOSC Federation is becoming more an operational infrastructure as well with a number of nodes. EuroHPC Federation platform, EJA Federation, plus we have other key infrastructures like that federate capabilities and digital infrastructure for science. Also here, there's a common shared capabilities. Going level up, this is more, say, strategic coordination, policy level coordination, still by, in this case, by scientific discipline. So we have the S3 clusters, we have some other groupings of organization by scientific disciplines. On the policy side, okay, on the horizontal side, we have the ERG partnership, ERG-PCGEU governance, and also I mentioned here like the EARG for more the policy around policy alignment around the infrastructures. Here, the infrastructure assembly is also a grouping of 5 key horizontal infrastructures, and the top layer we have the kind of the policy from the European Commission, and acts, and policy documents, communications, and so on. So that's the way I did. So when we think about okay, this type of endeavors, also there's a lot of players involved, organized in different ways, and all of this ecosystem in a way need to be converged to a common direction. And moving to the SRIDA, one of the key things we did at the beginning was to identify what are the key external drivers that we need to consider in shaping our priorities. One, okay, we already saw the scale of infrastructure that is needed to deal with. So the evolution of the scale, okay, the data, scientific data moving to the exabyte scale, and variety of infrastructures emerging, bringing to the need also to converge also on how to integrate the different types of infrastructures, and so on. The second one is the AI adoption. This has been, if you go back maybe 5 years ago, you would not expect this to be probably so prominent, but now it's changing. The explosion of AI is changing a lot. Many strategies in terms of investment, as we saw earlier, and we need to also change the way we can conduct science. So it's opening new avenues we need to consider. Environmental sustainability, it was mentioned several times. Security and trust, also with the, it will be very important, also with the evolution of quantum and so on. Long-term preservation, it's for all the type of digital assets involved in science. Workforce capacity, also the fact that, okay, industry is attracting a lot of experts, so how do we retain the experts in our community? And the last but not least, the important topic of digital sovereignty. How we can remain open for collaboration, but still be resilient to on the digital infrastructures that we use and technology. And in terms of goals, that we set for this SRIDA, we have the, first of all, one of the goals would be that we want to evolve and consolidate a coherent governance to ensure that the different players between the vertical, thematic research infrastructure, the horizontal digital infrastructures, and they keep the dialogue and the coordination among how to evolve this digital component for science. And then, okay, another goal, we want to ensure that we have easy resource access for, and that is compatible with the long-term life of the scientific experiments, and also with the suitable federated authentication mechanisms and so on. Technical interoperability, it was a key aspect mentioned earlier as well. Sustainability has different flavors. You can see from the environmental side, from sustainability in terms of being able to reproduce science in different systems over time. And the last one was to how we can ensure that we have, let's say, nice career paths for the experts and to retain them within our communities. The document is, okay, that you find in the LinkedIn agenda is split in two main parts. We split in two. Basically, the one document contains the, let's say, the core narrative. So how we approach the SRIDA, development, the strategic context that I showed in the previous slide, this big diagram with the different layers, the goals, then the 13 priorities organized in 4 pillars that are described. And then we have a section about investment areas, multi-annual roadmap, and a bit of narrative in terms of broader impact. The annex, which normally is quite a long annex, but it's quite important, especially Annex A, because Annex A contains the detail of each priority. So the way we did was first, we identified the priorities based on the gaps and the work of the technical blueprint, and also based on other analysis. Once we identified, these are the 13 priorities we need, we identified some key experts, and we gave the assignments to develop the priority according to a defined template. Once we had each individual priority developed, then we consolidated the narrative that you read here. So these are, the foundation to build all of this. And Annex C is also provide the evidence. What are the key messages we collected from doing all the consultations? So this is more, groundwork that led to the priorities, and from the priorities we went here. These are the 13 priorities organized in 4 pillars. The first pillar, we call it policy, trust, and governance. Then we have a second on architecture and interoperability. Third one is more the software application layer, if you want, software and science enablers. And then the last one is about the human capital and responsibility. I will then give some highlights for each of them. And but before doing so, I want to go back to how we described each priority. Each priority has 3 main sections. The one will answer more to the why this is a priority, why this is important from the strategic viewpoint, what is the current state, what is the community evidence, link to the technical blueprint in case of technical priority, and how it aligns with European key strategies. And the second one's about more what need to change. What is the future state? In the sense, what should be the future outcome, some qualitative indicators, and what will be the impact for Europe if we achieve it. And the third one is how to reach this destination with roadmap with 3 time horizons, split with actions by stakeholder, and some high-level view on what are the most important resources needed to implement it. So if you go to the Annex A, each of the priorities described according to this template. Now I will just give a key message for each of the priorities. And for the first one, is more about cross-infrastructure governance. It's more about how Spectrum brought together the different players like WCG, SKA, LOFAR, plus the horizontal infrastructures into a dialogue. But also we saw there are different structures already in this large diagram. The question is how we could evolve, or the formal part of the dialogue is not the bottom-up collaboration, it's more the top-down governance. How do we organize this dialogue for the future? The idea here would be, for instance, to have a formal kind of lightweight coordination forum where all these players can come back together on a regular basis and have a continuation of this type of dialogue we have in Spectrum. The priority number 2 is more in the area of federated resource allocation. Here we see that the individual scientific experiments, they have their own mechanism to get allocation for the member states, and so what we call these pledged resources. On the other hand, we see the emergence of these European flagship infrastructures like EuroHPC and AI factories, which have a different logic in terms of location and also different time horizons, if you want, also different scope. And the idea is how do we ensure that we can integrate all the different capabilities we have into a federated resource allocation mechanism that allows to provide the stability to the resources needed by science. So on one side, okay, there is a need for the communities to make clear, okay, what are the needs for the lifetime of the instruments, and on the other hand is, okay, how do we enable practically the mechanism and also have a counting system that can measure the usage in the various mechanisms that are compatible. The third one is about federated identity and trust. Here we have a lot already done, the groundwork for interoperable authentication of the authorization systems. This is started more from the digital infrastructure, from the horizontal digital infrastructures, with the recent ARC3 project that also are moving more also to be adopted by research infrastructures. Here the work should continue to integrate also, we know for instance EuroHPC have developed this federation platform, which is also integrating a key AI system that is compatible with what is being used by other infrastructures. So this work needs to continue to include, to be comprehensive for the all resources needed by science. And also there is a new actor, like we have, not only, we are going in a world where there will be not only humans accessing resources, but also agents. And that will require also an evolution of what we currently defined. In the pillar number 2, which is we call more in the architecture and interoperability, we have the first one is connected to the heterogeneous computing integration and how we can ensure unified access to the different types of computing architecture systems available. And the second one is more connected to the data part. And so here, for instance, there is a suggestion to run pilots to move data at the exabyte scale and to ensure that the network is compatible with the needs of the next generation instruments, and also to ensure that we have a controlled access to the data through policy definitions, and also establish this cross-domain fair data management capabilities. In the last layers, more the build on top of this, if you want, is more the workflow. So how do we run workflows across the different systems, and especially being able to deal with the long-term running workflows, or and ensure they can be reproduced over time. Moving to the pillar number 3, the first one is the AI. So here AI comes in different flavors, and you can have different angles in which AI is important. First of all, we will have AI-enabled scientific workflows, so we need to have the AI capabilities to support them that integrate also in the more traditional infrastructures. We need support for distributed training, federated learning, and also being available to allow or to experiment with new way to conduct science with AI capabilities. The priority number 8 is more about the software portability. That was also a topic that was recurring in the panel before the technical blueprint. And here is the strategic level wrapping of the topic. So it's about how we can run code on different systems, what are the kind of frameworks that are needed to allow this, and ensure that they are available and agreed and usable. The priority number 9 is about the open science and reproducibility aspect. This is very important, especially in connection to the open science policy. And this spans not only the availability of data, but also the capability to reproduce computational environments, and and have all the assets needed, software that we can run for a long period of time, so that we can, reproducibility is a kind of key capability by default for science. And the last one is the software preservation and sustainability. Here we know software is very important component. It was mentioned before also, not often receiving the adequate level of funding, especially for maintenance. They say the new things usually is more sexy to fund, but to maintain, say, running systems, running software for a long period of time is very important, but not usually given the right priority in the fundings. And here there are many initiatives around, for instance, developing software management plans, or having a system to preserve software, and educating the new generations on software maintenance and so on. And the last pillar, we call it human capital and responsibility. Here we put here the environmental part here, because in a way it's an important, although there's technical, let's say, implications, is more about the wish that as humans we need to take care of our, it's more, starts from the, let's say, the willingness of creating systems that are more environmentally sustainable. So that's why I start from the responsibility we need to put on ourselves. So from the first one is more the bottom-up collaboration, basically what the community of practice did in Spectrum. How do we continue this bottom-up collaboration between experts to evolve the technical blueprint and make sure this is adopted by the decision makers. The second one, as I mentioned, is more in connection to environmental sustainability. How do we procure the future systems? How do we allocate resources in a way that we raise awareness of the importance and the impact on the environment of the use of these infrastructures? And the last one is more about ensuring, let's say, a career path that that offers a growth opportunities for software research engineers, and they are, say, willing to remain and grow in our community. So here already there is a lot of pre-existing work we built on, and for instance, the recognition of research software engineer career in our community would be very important. The strategic research, innovation, and deployment agenda comes also with the roadmap. This is just a very high-level view, where I picked up one topic per time horizon. We have 3 time horizons, 3 years, from 3 to 5. So first 3, second 3 years, and then 5+. And we have, okay, here each of these time ranges, they have a kind of an overlapping period. And for each of the priorities, we have defined actions for each time horizons. They are mapped also to these 3 stakeholder categories. So we have scientific community and research infrastructures on one side, software providers and infrastructures, and policy and funders. And these are described more in details also in each individual priority. And the last message would be also, we kind of highlighted in the document what are the key priority investment areas. And we identify, of course, okay, we have the computing infrastructures and the different flavors of architecture that are needed for science. Then also the data infrastructure is very important, because, okay, that's the data where is the starting point where the results of the scientific experiments are stored and made available for processing and reuse and preservation. The software and tools and that are needed to run the scientific workflows and analyze the data and Then the governance and coordination layer, and the human capital with the research, software engineers, careers, investments, data specialists, and so on, training, and so on. In the documents also, we highlight a couple of items that are usually underfunded. For instance, the software maintenance, as we mentioned before. And also there is some cross-cutting investment areas that cross all these 5. Like open science, you can basically has an impact on all of them. Like from the careers to the way you make software citable, data citable, and reusable, and so on. And environmental sustainability after. And with this is my last slide. So I think now we will follow the same approach as done before. We will have a panel, and then we will also open for you to have some engagement. And I suggest then the panelists for next session, if you can. Thank you. And okay. So here, so Xavi will be the panel moderator. And here we have the list of the panelists that I invite to join me on the stage.
Okay, so if we are ready, so I'm Xavier Salazar, I'm from the EGI Foundation, and I will be chairing this SRIDA panel because Sergio is going to be part of the panel. So let me present shortly the members for the panel. So the first one is Sergio Andreozzi. So he's the director for strategy and innovation of the EGI Foundation, and he has been the coordinator of Spectrum Project. We have Serge Bogaerts, he's the praise director, and he will be speaking in representation of the HPC community and quantum and other future new technologies. We have Consencio Bossi from INFN CERN, and he will be providing the perspective of the HLLHC. And we have Chiara Ferrari, and that she could not reach out due to the strikes yesterday, but hopefully she's online. Yep.
I'm here. Yes.
Welcome, Chiara. So she's the SCA France director and the scientific delegate for CNRS, and she will be providing the radio astronomy, or one of the radio astronomy views. We have Estela Suarez, so we already know her. She has been delivering a very interesting keynote this morning, and yeah, she will share her expertise. We have Pantelis. Tziveloglou from the European Commission. We also know him from this morning, and we also have Michiel von Haarlem, the director of LOFAR, and he will also complete the vision of from the radio astronomy point of view. There's a difference between the technical blueprint, so the SRIDA is the higher level policy implications. So we have several slightly different questions that hopefully are going to be quite controversial, so that we can wake you up after the coffee and the lunch. And yeah, we also ask you to keep short the answers so that we can also foster a bit of discussion. Okay, so at this, we would like to thank you all for being here, and yeah, let's start with the discussion questions. So the first one, so we have been presented like several times already this morning and before at the SRIDA, like there is this differences between how the resource allocation across the continuum is being awarded. Okay, so there is on the one side the need from the data-intensive science, big experiments, like to have like very long allocations because their experiments keep on generating data like across decades. Whereas traditionally European HPC infrastructure have been like following this approach for peer review allocation, and which maximum lasts 1 year. And it also has some historical reasons. So we would like to ask, like, how does like this resource allocation process need to change, and yeah, what are the topics that are blocking this? So we would like Consencio to start, and then Michel, Estela, and Sergio.
Okay, yeah, first of all, thanks for inviting me to this panel. And yeah, I mean, coming from the WCG side of things, I think that the single thing that blocks this large-scale allocation is that these HPC centers, let's take EuroHPC, give you allocations by site and by project. So this means that, I mean, an example which comes to mind is, say, some lattice QCD person that wants to do some calculation has a pretty idea, he or she a pretty idea of what they need and the computing needs and so on and so forth, and then uses the resources and publishes a paper. Now, LHC experiment, but also, I mean, other experiments, energy physics experiment, publish of the order of 100 papers per year, per experiment. And I mean, so basically what I'm trying to say is that while the equivalent of in our side of an allocation would be just on top, a thin layer by which the analysts do their final processing, and the vast amount of computing resources that we need are used for centralized processing of all data that come out from our detectors. And therefore, I mean, these are reconstructed, analyzed. There is digital twins of our detectors that are used, so if consistent fraction is done to do. There is an ecosystem in our experiments that covers all this. So we know in advance our instruments, how long they are going to take data, LHC until end of 2041. And we know that, I mean, our computing model, we have set up computing model. So from this data taking schedule, digital twins, and computing model, we have a pretty fair idea of the computing resources that we need between now and 2041. Well, there might be factor 2 discrepancies, but I mean, it's not order of magnitudes. I mean, you will not go very much beyond this. So, and at this point, I mean, the question is how do you get these computing resources? I mean, you can understand that this is not, a single year allocation is not what you really need, and we work on a much larger scale. So I would say, yeah, that this creates some problem, because when you ask for an HPC allocation, you basically have to do some, I would say, paperwork to motivate as peer-reviewed. And by the way, when we say peer-reviewed, our resource requirements are peer-reviewed by our funding agencies. So it's a process that goes on every 6 months. We do resource requirements, and we go to a certain resource review board where all these requirements are reviewed, scrutinized from the scientific point of view, from the technical point of view, from the software computing point of view, and this happens every 6 months. So there is this heartbeat of our computing model and resources evolves, it's constantly monitored. So I mean, I guess that this is basically the reason why we need more different allocation mechanism. And by the way, I would also say that in some countries, some member states, the HPC allocation is done. We have some HPC resources allocation under the national agreements between funding agencies, member states, and the HPC sites. I'm thinking about, for instance, Cineca, where the INFN Tier 1 has allocated resources. This is done under the umbrella of the national resource allocations. It's not a global HPC thing. So, I mean, to conclude, I would say, I mean, these are the main reasons that require longer allocations. I mean, so.
Okay, so thanks a lot. I think it was pretty clear. And so we wanted to continue with Michael, so that now we got the vision from the high energy physics. So now we jump to the radio astronomy.
Okay, thank you. Let me start off by sketching the difference between LOFAR and, I think, SKA and CERN's instruments, let's call it that. I think the scale is quite significantly different in terms of certainly the overall funding and the amount of money that's available, the resources as well. I think also SKA, in many aspects, is a community-led thing in the sense that we have stations dotted around Europe and the community is based around those stations. They come together centrally as well, but there is a high degree of kind of bottom-up funding that supports our operational model. And that's the kind of legacy that we have to acknowledge, and we're not going to change that much. So that's an important factor. But essentially what we're facing with LOFAR is that we've built a telescope that generates considerable amounts of data, and that needs to be integrated with the compute backend, which so far we haven't been able to secure long term. And basically what that means is it's left up to the community to cobble together those resources and to find a way out. Initially, I think when we first got going with LOFAR, that was an acceptable strategy because we were breaking new ground. We were doing things for which we didn't have the software and the tooling available yet to actually process it because we never had that data. We could never look at the sky with this sensitivity. And so the first couple of years, we were finding our feet and figuring out how to do things. But over the years, that has improved dramatically. And now we have professional, well-run pipelines that deserve a compute infrastructure that is, well, essentially allocated at least on a more significant time scale, or at least commensurate with the allocations of those projects, for example. And so our projects typically run for 4 to 5 years. And so that's the kind of allocation model that we're looking at, and that simply doesn't match the resource allocations that HPC providers, for example, give us. So that's one of the concerns that we have. And so we're really keen to see whether there are different ways of going about that. I don't think we're talking about taking a huge chunk out of the HPC budget, but it is more about that there is a demand for a different allocation model than the traditional HPC resource allocation model that exists.
Okay, so thanks a lot also for the statement, and we continue with Estela and provide the infrastructure view.
Yeah, so maybe from the HPC side. So my initial reaction to this is be careful what you wish for. Because the main underlying problem of this situation is that HPC resources are shared resources. So right now, the 1-year limitation is just to make sure that every year will be these resources available to the full community, and someone will be chosen depending on the peer review process, who are the right people to get the next allocation. Now, you can think of a model in which these cycles are longer, so it runs for multiple years. But then once you have the decision for the allocation for multiple years, the decision is taken until the next block of multiple years. So if you are not part of these awarded communities, you are in a big trouble. So at the end, for me, the single thing that blocks all of this is that there is a limited resource that has to be shared between all so many communities. So we have, there might tune into the model that we use for compute allocation, but it will not change the underlying situation that there will probably never be enough computing for everybody. And the same applies for data. So data storage, one of the challenges is that it hasn't really been part of EuroHPC, strictly speaking. So procurements has been done always for compute in EuroHPC, not for data. This might change, at least that there is a willingness and a wish to change that. Then allocations can be for compute and for data storage, and storage probably running in longer cycles. Still, always a shared resource, so nothing that we can really do about this. What is the right model is a question to be discussed with the communities. What are the real cycles and durations?
Okay, so thanks a lot. And so we see here like these wishful dreams that we were told this morning by and the realism. So we close this question with Sergio.
Yes, I'm gonna give a perspective also from the EGI viewpoint. That is a federated infrastructure where the provider are national research center that are funded by the government, so it's more, I'll say, country-based infrastructure development, as opposed to the EuroHPC, where it's more, say, EC-based. And so normally the way we operate is the following. When we get a new community, normally EGI serves international research communities, when usually they come up with a new scientific problem and they ask, can you help us getting access to the federated infrastructure? Normally we don't have any pre-allocated capacity. We already do a negotiation with the different providers, and we need to agree with them, okay, are you interested in supporting this community and this type of science? Does it align with your national priorities and so on? And this is a very manual process at the moment. And on the other hand, also we heard from our partners that they also, the level of, let's say, paperwork, let's call it, or compliance they need to do is increasing at the national level to offer capacity to the research communities. Something that would be useful maybe to, although each country they have their own regulations, procedures, etc., it would be nice to harmonize more the way these requests are made and facilitate the work of maybe demand aggregators like EGI Federation to be able to, say, do the work once and then split maybe the requests from the different providers. And maybe also if this is harmonized between the countries and the EuroHPC, then it would make also the process more smoother and with less friction. We'll say maybe they will be faster also. And will allow research communities to more easily find the resources that can go from high-end HPC, cloud, high-throughput computing from the different providers that are available in Europe. That would be my...
Okay, so thanks a lot. I think we could get like a good feeling of the different views that we have. So as for the speakers that didn't talk, now you'll have the chance to also start contributing. So the next controversial question, so we have been also discussing here about the role of AI in the continuum and this trend that it's not always like in line with the scientific needs, and especially this tendency of getting like lower precision hardware compared to the needs for the traditional experiments, methods, simulations of the communities. And yeah, Tommaso is not here now to be in the controversy, but we have Estela to start at this point. And
I have the feeling I'm here to annoy people. Because, so I spoke already on my talk about the need for a kind of collective lobbying to bring to the funding agency the importance of the key priorities and the requirements from the communities. That's clear. However, the problem with the reduced precision hardware, as I already said before, is not only a political problem. It's mainly a market problem. And I doubt that this trend will change quickly. So I don't think that we can keep into the comfortable position and say, I will continue doing my workload as I've been doing for the last 20 years and hope that things change. We see this when GPUs came. People tried still to continue running only on CPUs for a while, and at some point the technology trend was so clear that you cannot really live without it. I have the feeling a similar thing is happening with this low precision, so my recommendation would be try to reconsider and reanalyze in which areas maybe there is a chance that you can at least make use of part of this, to exploit as much as possible the hardware as it is, and yes, involve in co-design with vendors, try to stress again the importance of the other requirements that there are out there, being aware that at least the large vendors will always be driven by where the money is, and the money is not in traditional science and HPC, unfortunately. But maybe at European level, we can do some co-design with local developers that, as I said before, can have some niche development for this kind of communities. Yeah.
So thanks a lot again for this realism. And yes, since you mentioned on how we can, or what we can do on the European level, I think it's the right moment as well to have Pantelis to see how, like from the EOSC side, can be supported.
Well, I'm not going to change the narrative that the market is going in a certain direction and there is not much you can do about it. The point I would like to highlight is that indeed lobbying is important, and it's important when someone lobbies to have a good overview of what are the right channels, let's say, that can be used for lobbying. And of course, EuroHPC has been highlighted quite often here, and it's important to bring these needs as much as possible and try to influence the direction of EuroHPC to serve also your needs. However, you should also be looking into other directions. EOSC could be one of them, and we'll be happy to see how much we can contribute to serving these needs. Of course, EOSC core business is more about data interoperability, data federation, rather than computing. Nevertheless, our core business is also researchers, so this is the community that we're trying to serve best. And the overall scope of EOSC has been evolving over the years. For example, sovereignty of critical data is something that is now increasingly being correlated with EOSC, and this was not 2 years ago. So if a strong need comes from the community also for some types of computing, we could also see how the scope of EOSC could evolve over the future to cover these needs. But I would say not even EOSC per se, not even EOSC in restriction, but also overall the support from European programs on the development of research infrastructures, and also the development of applications and software for research. It's not only through EuroHPC, for example, or EOSC, it's also through the overall part of Horizon Europe that supports research infrastructures. There is the infra calls in Horizon Europe. They also have several calls on technology development, on development of infrastructures. So there you could find also maybe opportunities to accommodate some development that needs to be done in order to bring your workflows closer to what kind of chips are being developed now that were not there in the past. What is currently missing from Horizon Europe is the funding of building infrastructures. So the Horizon Europe Research Infrastructure Work Program cannot fund the building of infrastructures in the way, for example, that EuroHPC is doing with the computing infrastructures. The reason why I'm referring to this is because from the Commission side, we have proposed for the next Horizon Europe to also have the possibility for the program to also fund the building of the building to support the building costs of infrastructures. Up to a certain percent of 20% is set in the Commission proposal. So this would allow also Horizon Europe to provide funding directly for buying certain types of infrastructures, for building these infrastructures, including, of course, computing infrastructures. Is this already agreed? No. This is the Commission proposal. Now it's being negotiated with the Member States and the European Parliament. But if this makes it in the regulation and becomes part of the next Horizon Europe, this opens another opportunity for the community to look into investment opportunities, funding opportunities, not only for the types of activities that Horizon Europe is currently funding, but also for actual building, covering the building costs of infrastructures.
Okay, so thanks a lot for these insights and these follow-up ideas. So hopefully, let's see how this crystallizes. So we continue with Consensio.
Yeah, I mean, glad to hear your last sentences. Your last. Well, okay, anyway, we'll see. No, but I mean, I tend to agree with Estela saying that there is some kind of friction, between the coming of new technology and the adoptions, and we try to be conservative also because, I mean, remember that if you run an infrastructure, a scientific infrastructure for decades, I mean, you need to have some backward compatibility what they are done. But nevertheless, I mean, in our field, the usage of GPUs after some initial friction, I mean, is taking up, especially in tasks which involve parallel processing. I mean, this is like reconstruction tasks and so on. What is more difficult to do to use this kind of heterogeneous resources, including be they low precision, high precision, whatever, it's secondary, it's importance. It's again the digital twins. We need a consistent fraction of our resources for simulation, and then simulation is Monte Carlo simulation. You have a lot of branching, and then this inherently doesn't work very well on GPUs. So I mean, to this, you can say, okay, let's throw away our workhorse that has served us for 20 plus years, which is Jam4, not to be confused with the giant networking enterprise. Jam4 simulation program that takes care, I mean, has all the physics process to a very precise level and to over a vast range of energies that we use in our detectors. I mean, so this is very detailed, but all cannot work efficient on GPUs. So, I mean, what's the alternative? Okay, let's try to see, and this we are trying to see that if we can have some machine learning AI approaches to simulation. Of course, I mean, this is a daunting endeavor which needs a lot of resources, and I would say a lot of human resources, because it's a change of paradigm that then you need to validate, and you need to convince old school physicists like me that, I mean, this kind of approaches are valuable over the classical way of doing things. But of course, I mean, this is just to say that there is the need to exploit this in more details, and there you need a lot of effort to do this. And then the same applies to precision, to floating point 64s versus floating point 8. I mean, at some point, I mean, we have to see whether all the calculation that we do on floating point with doubles, I mean, given if we publish measurement with a precision of 1%, you don't need floating point 64 all the way. I mean, but again, this is a very difficult task to study, because again, you need people to do that. We have been trying in the past to study this. What changes if you change the precision on the algorithms that you use in your workflows, and then this is really a very difficult situation, because you are dealing with software stacks that are not 100 lines of code, so it's much more. So it's a few millions lines of code. So it's of course, you use a test case of limited dimension, but I mean the amount of work you need to do for studying this kind of issues needs effort, right?
Okay, so thanks a lot, and we close the question with Sergio, and I would like to speed up a bit, maybe, because time is running, so we are in the half of the session, and we are closing the question too, so...
Yeah, I'll try to be brief. So on the AI topic, okay, one of the aspects that definitely we need to make sure that together we do proper, say, lobbying or advocating the use of the facilities like AI factories and data labs, etc., will be available for science. As we know at the moment, okay, the priority is not very high, so we need to make sure that will be available. The second is that I would write, this was very inspiring, the study that Estela made today. It would be very interesting to expand the same study to national level, to understand what's happening to infrastructure, investment in infrastructure in national research and data center, because they are, at the moment, they are serving a lot of the research needs. So we need to make sure that, okay, the investments in those data centers will be preserved, and they can participate in the full range of AI-powered workflows. We just don't need only large-scale infrastructure to train models, but for inference and fine-tuning, the national research data centers can do very well the job, and also they have already the connection, the relationships with the research communities, and so that's why they need to be part of a wider ecosystem. And the last one, the last message, yes, that we need to have this coherent ecosystem where we don't put, like picking up on a sentence was said today, all our eggs in a basket, but we integrate all the different systems and we ensure they are available to support research.
Okay, so thanks a lot for the complete views. And now we go to the next question, and we will hear like other people. So we will start with Chiara, and it's about, so we had this topic as well on governance and long-term representation. So what will happen next? So Spectrum, within Spectrum, we built like a very interesting dialogue between communities, infrastructure providers, and policymakers. And yeah, we believe that this needs to continue. This has been helpful, and this needs to keep on being helpful. And we also wanted to provide like some views on how this can happen or can be done. So Chiara
Yes.
will start.
Can you hear me? Can you hear me well?
Yes.
Okay, so my apologies. Of course, as you can imagine, after all these years of work together, it would have been much nicer to be with all of you. Anyway, so of course, this is a key question, a key challenge, because if we do not maintain a coordination mechanism that bridge the infrastructures and research infrastructures in data-intensive domains, researchers will continue to experience boundaries that, as very well described by a word in the SRIDA, that is a friction, that we can experiment if there is not this dialogue. So with this friction and without such a conversation, not only it would be a big issue for researchers, since the utility of the infrastructure would be significantly reduced for researchers. But of course, it would also be an issue for the infrastructures themselves, which are built and funded precisely to be used by scientific communities, in addition to some industrial use, as we heard this morning, of course. So to me, the mechanism that can work is a sustained and reinforced coordination forum with a clear mandate, and that should include the free constituencies on equal footing. the data-intensive research communities, the digital infrastructure providers, and of course the national and European funding bodies, each with a different role. And let me add 2 points to give my opinion to have this working, and this from a researcher perspective. So in terms of scientific communities, as mentioned very well this morning by Pantelis during his first talk, we need to be able to raise our voice. And for this, we need to be able to discuss between us and to align the position of different scientific communities in terms of needs, in terms of knowledge, as we started to do with Spectrum. And as we will discuss much more extensively at the end of the meeting, the Spectrum community of practice aims at keeping this discussion alive and open in such a way to work together and not in competition with already existing and established networking organizations, because we need to keep in mind this. Of course, we try to discuss all together. Of course, we managed, but there is much more outside that already started to do this. So we need to work in a coordinated way, and we will try to give some perspectives in the last presentation. And finally, this has to be linked with funding schemes, in particular because a working dialogue on governance models needs absolutely to be fed by technical developments. As stressed by Estela and Maria, among others this morning, data-intensive communities need support to reach the same maturity level that classical HPC communities have achieved in using advanced infrastructures in order to provide the right level of input that is required. Otherwise, in the exascale and post-exascale era, Europe risks having excellent machines and services, but an insufficiently mature mechanisms for some of the communities that most need them. And so this gap between the classical HPC community and the data-intensive communities needs, in my opinion, to funding schemes to feed all this. And I stop here.
So thanks a lot for kickstarting the questions. So and looking forward to hear in the next presentation, because this will be somehow bridging this. So we will continue with Michael.
Yeah, it's an interesting topic, and a bit of a shame that we are asked to talk about this before we've had the collective thoughts of within the panel. But let me say from a LOFAR perspective is that keeping the dialogue alive sounds great, but we need results on a shorter time scale. LOFAR is undergoing an upgrade now, and we will be operational, say, within a year, 18 months from now. And so there is a degree of urgency, and if we don't manage to move towards, or at least have a perspective of this different model, then we will be back to square one, basically, how we operated under LOFAR 1 between 2011 and 2024, which places the burden, or at least the lion's share of the burden, within the scientific community. And that's, we miss one of our goals, which is to provide a higher level of service to the community, to unlock the users. Radio astronomy is technically challenging to get into. It requires a lot of investment in time to build up the knowledge and the confidence to be a player there. And we wanted to lower the threshold for new communities, not just in Europe but worldwide, by making available, say, higher quality and higher processing level of data to the user community. And so that's one of the goals that will probably suffer as a result of that, which is unfortunate. So I'm in favor, and I'm willing to do everything I can to be a part of this dialogue, but I would like to see some results sooner rather than later. So some projects can afford to take on this dialogue for a few more years, but for us the urgency is a little bit higher.
So thanks a lot. So hopefully we can bring this forward and at least to make these results of the dialogue be heard. And so we close the question with Pantelis so that we can also hear the vision from the,
Thanks, yes.
the policy side.
Well, my thoughts on this question were also reflecting on what you have presented in your roadmap. Is that there is, of course, I fully understand that there is a need to continue the coordination and to continue the dialogue within this community for all the data and computing continuum. But at the same time, I fully appreciate also the point made that some of these aspects are now already mature to be implemented. So the question is not really continuing the dialogue, but actually moving towards implementing these aspects that are in the roadmap. And to this point, I think it would be useful as much as possible to fully exploit existing fora and coordination mechanisms that exist, instead of kind of coming up with a new one next to the others. And we can take the priorities, the 13 priorities that you highlighted, and see, for each one of these priorities, where could effectively this community influence the broader discussion, and the existing coordination mechanisms that exist, that are in place in Europe include, of course, EOSC. Already there is a multitude of different working groups, task forces, coordination mechanisms, fora, that touch upon very much the same angles that you have here. So AAI, catalogs, interoperability, computing integration, orchestration of workflows. These are common problems also in other thematic areas, and they are being discussed in this fora. So the input from data-intensive disciplines, I think, will be very useful there, and which also provides you with some kind of framework of having a visible implementation of these priorities. SRIDA, of course, is another area that you can exploit in terms of bringing these needs to this framework. ERIC, LOFAR is an ERIC, there is an ERIC forum. These certain aspects of the needs of different scientific communities are discussed within this fora. Then, of course, for what concerns physics and astronomy, I was highlighting, and I think it was also highlighting in the previous presentation, the project that led to the science cluster ESCAPE. So there again, there is some kind of community that has been living for some years. Of course, the project is not running anymore, but I understand that there is some kind of coordination of within the ESCAPE and also with the other science clusters. So my overall message is important not to forget that in order to arrive to some kind of real implementation solution of what is highlighted in the roadmap and the priorities, to exploit as much as possible existing frameworks, existing coordination mechanisms, and try to influence those mechanisms in order to get the funding and the support that is needed to get this done.
Okay, so thanks a lot, and this will serve as an introduction for later presentation. So let's jump faster, and I would like to, if we can even speed it a bit more up, because I also want to hear about search, and you are in the last two questions. So next topic, and again on what's happening next. So what about the data and the long-term preservation? So how can we find an effective way to ensure the preservation and the reuse of all the large-scale data collections and everything that, so we have invested a lot into the generation of this data, so how we can keep it, okay? And so we have Consensio, and yeah, as said, if we can be fast, a bit faster.
Yeah, let me try to speed up, but before, effectively preserve and reuse large-scale data collection, I would like to say that, elsewhere, this is not taken into account at all. Because I was in an experiment in the year 2000, so 2008, where, the experiment finished taking data. This was in California, this is Stanford University. The experiment finished taking data. Then after a couple of years, well, 3 or 4, the host lab said, okay, go away. And then, I mean, we have to invent a creative way to keep this data in our European compute centers, tier ones in Germany, France, and CERN. And this is, and same happened for other experiments in the US, particle physics experiment in the US. But okay. So I would say that compared to these experiments, we're not so bad. And we have in energy physics, we have a data preservation group that has been active since many years now. You can still analyze data collected from experiments that ran in the 90s, the accelerator before the LHC at CERN, for instance. But nevertheless, I mean, this is not we're still far to be perfect. I mean, especially now that with the current instruments, they generate data that are order of magnitudes much higher. We have seen all that, right? So there are various responsible communities. First of all, scientific communities, research infrastructure. I mean, follow best practices. The CERN Open Data Working Group has done a very good work in trying to understand, and also the Open Data for App Working Group, to understand the various tiers at which data should be preserved. Of course, I mean, if you go low in the data tier and go to the data that are closer to detectors, you need some domain knowledge to preserve this. Of course, at some point you have to find a compromise between the level of preservation. You preserve higher level objects where domain-specific information perhaps is less. But the scientific communities have the task of providing not only data preservation but also preserve workflow, reproducibility, and in all metadata, which is pretty important, where domain-specific knowledge is necessary. So, but of course, then you need also to provide software to run reproducibility checks, continuous integration, all that, and this is perhaps more in the remit of infrastructures. On the other hand, the funding agencies have to provide resources for that. And again, human resources, I'm afraid, it's also a word that we need to mention. Right.
Okay, so thanks a lot. We continue with Michael.
Yes, this is about responsibility, right, and funding, essentially. And my line on this is quite simple. I think we're in ERIC, and we have fairly stable funding, at least for 5-year periods at a time, and we have definitely a long-term perspective on this. And so I would like to see us take responsibility for this in the long run. I think there are ways of, the burden in terms of cost will probably decrease over time. Historical radio astronomy archive from a telescope that might be operating 20, 30 years ago fits onto a single drive right now. So in that sense, technology will even make the, petabytes, I'm not going to go to the exabyte scale quite yet, but the petabytes more manageable than they appear to be today. And I think, we look for the longer term, of course, in EOSC, and that's one of the areas. I mean, one side, of course, is that, as we heard today, also that computing is still somewhat underdeveloped in EOSC, and I think when it's say it's archival radio data, some compute is probably still required, and so we'd be interested in, say, seeing where the computing side of the EOSC goes in that regard.
So, and very nice for bridging to Pantelis and to see how this can be tackled by EOSC.
Yes, thanks. Yeah, absolutely. This is, of course, a major challenge and priority. Within EOSC, we try to contribute a little bit to supporting this priority with a call in a couple of years ago. Now there is a project running called EOSC Eden, specifically focused on developing capacity and coordination in Europe for long-term data preservation. there are several challenges, right? There's an issue of data governance, so which data need to be preserved, which need not to be preserved, given that there is limited resources for storing this data. Then in terms of standardization, in terms of community to support all this curation that needs to be done for the long-term preservation. And then, of course, the mismatch between funding, which is mainly project-based, and this long-term kind of activity, which is to be able to have a safe and long-term storage solution for a certain high-value data set which can run, of course, beyond the project's lifetime. So these are obvious challenges that we are all facing, and it's also from the side of Horizon Europe or the Commission, which is almost exclusively project-based. There is a limited instruments that we can use in order to support this activity. But I think it's important to have, at least some kind of coordination at European level, and EOS can provide a platform for coordinating also around data preservation, so that we can at least have some kind of coordination between European funding, national funding, and what is coming up as priorities, and those data sets that are high value and need to be preserved, so that we can at least have a proper identification of solutions and properly implement them at European level.
So thanks a lot. So that's very interesting insights. Then we had question 5. I had foreseen it to be optional in case we had time. So we have, I can foresee like 10-15 minutes. I think I would like to hear Serge Bogaerts, that we haven't still heard from him. So maybe we can take the question. It can be interesting. Yeah, please.
So the question is about sovereignty, if I'm not mistaken.
Exactly, yeah. So let me get to the question. So we have been speaking about the sovereignty around, during the day. So how can we ensure like all these threats that are coming from the outside, so that we can be protected and we can protect both data and digital sovereignty in general, without compromising the development or the scientific developments that we are doing, and as well without compromising the international collaborations that we are having, because we are talking about experiments that are like broader than Europe.
Yeah, interesting turn of the timing. I have been to Helsinki, invited to an open geospatial consortium that was discussing this. So these guys are dealing with the geospatial data, faced with exactly the same challenges that we all are within our domain, and asking themselves the same question about being sovereign versus being open. And out of that discussion came several interesting ideas. One, I believe, is being pragmatic, and I believe that today we should maybe think a little bit of being more pragmatic. And so one way to tackle this is first realize that science and the world in general is global. So isolating ourselves, we probably don't have the resources for that. A pragmatic way to approach this is to say, well, how about analyzing our dependencies and putting a criticality on these dependencies, and then plan for mitigation of the risk, and have alternatives to deal with these things. And I believe this is very much aligned with how Europe works. I mean, we have resources in being diverse, so we probably also can cope with, having creative ideas to fix dependencies. So I don't believe in developing a European sovereignty as like a big goal, but rather as being, attentive indeed that to defend our values, we should be limited. We should have limited dependence. And basically this is what I wanted to say on sovereignty. If you allow me quickly, I just want also to share the fact that we, indeed, as Philippe said this morning, we released our scientific and innovation case for HPC, for computing in Europe, actually, for the coming 8 years. And a lot of the recommendations and findings we have in that publications are matching your question. So despite the fact that you are focusing on data-intensive applications, I can tell you that we share a lot of your ideas. And on top of that, I would like to, in a way, apologize because this peer review approach has been, fostered by praise for so many years. And actually, if you look into our recommendation, we call for discussing different access models. And we have tried that in the past, and we continue to try to discuss with communities to come up with different ways to approach access models and find alternatives to this peer review approach, even though I agree, Estela, watch out for what you wish for, indeed.
Yeah, so thanks a lot. So indeed, this was also very relevant for the question 1, actually. So thanks for reminding and for raising it. So we can continue with Stella. So sorry for not starting.
No. I was actually going to suggest the same thing. I wanted to hear what Serge was going to say. Maybe a personal comment. So for me, sovereignty is not really about being completely autonomous from everybody else and isolated, but it's about having choices. So having the different choices on the table between which you can choose from and having the security that you will have access to some of these choices at least. So that you will not be blocked out by someone else. It's not really an initiative, but the way I perceive it is not Europe wanted to isolate itself. Is Europe going to protect from the case that they would be trying to isolate us from outside? It's not us closing the door, it's making sure that if someone else closes the door, we have a choice. Yeah, and I'm not sure, so I would have the hope that from the scientific perspective, from the pure scientific community like high energy physics and astronomy, that is not so much of a problem in the sense that, there is a very long tradition of sharing data worldwide and having open data worldwide. And there is less of a danger that is being used for bad things, let's put it that way, for defense or stuff like that. So I hope that in your cases, you're in a better position that it is, I don't know, in medicine or in some other areas where data safety, security, and so on is much more of a problem. Yeah, these are just my thoughts on this.
Okay, so thanks a lot. And yeah, we finish. So thanks, Pantelis, because it's really good to have the policy view as well.
Yeah, so this is a bonus question, right? It was not planned. I thought you put it here because of the tech sovereignty package that was presented today. So that was the Commission presented the tech sovereignty package, not focusing on research, of course, but including research in some aspects. And this, of course, is more or less the discussion that we have been having in the European level around the overall technological sovereignty, including data sovereignty, vis-à-vis, of course, the United States and the changes in the United States, but also as an overall approach from Europe. And I like very much that the title already includes without isolation, because indeed, very often, European sovereignty is misinterpreted as European isolation. This is not the case. It's more about having choices. It's more about managing dependencies and making sure that researchers in Europe, they can and they do have access to the data they need to perform cutting-edge research. And indeed, for physics, we have not seen it so much as an issue in terms of changing priorities from other countries. It could be in case of cutting funding. So it could be some kind of disruptions from cutting funding, because we have seen several agencies from the US side to reduce their overall funding, especially for infrastructures. But it's much more prominent in life sciences, in health-related infectious diseases, in climate science, in social science and humanities, gender science. There we have real existing issues with databases being shut down one day after the other, with data collection, broad and very important data collection exercises being disrupted, or even data sets being skewed, changing the data so that specific elements are not mentioned, like climate change, for example. So there we have a problem, and there we had to act also, so that we make sure that, as I said before, that the researchers in Europe can rely on, can have reliable access to these important resources. So, of course, when it comes to to the way forward, it should not be isolation. It should be making sure that we have the capacity in Europe to serve our researchers, but also collaborating with countries that are willing to collaborate on these terms, on the terms of putting science first and not political agendas. So this is what I understand that this is the overall strategy that we're following for the future. And this, of course, implies an increased investment from Europe to this kind of capacity that is necessary to overcome the disruptions that are happening outside Europe. And I think more or less this is also the direction that the package that is announced today is following.
So,
just to close, just to make, not in relation to this question, but to make an interesting connection with the open source point that was raised in the previous panel, that whatever was developed in the world, in the WLAC, it was open source. Combined with this package on technological sovereignty is a European open source strategy, which I find interesting that it comes together with a technological sovereignty package, because it is proposed as a kind of a way for Europe also to achieve sovereignty by leveraging the open source movement, which I think it's interesting also to reflect from research side being proponents of open source globally.
Yes, so thanks for pointing this out. Yeah, I wanted to conclude with this, like be open to be sovereign and to be able to keep open so that others cannot close. So that's a very good point. So it's 40 past 3. Do you allow me to have like a couple of extra minutes? So I had foreseen this one take-home action like that you consider. So if we are able to go through very fast, like to just one, very short, then maybe we can keep one question from the audience. Yeah. Okay, so that's for everyone, and we can start by order, maybe with Serge. Take.
Okay, well, of course I picked 3 instead of 1, but I won't give you the 3. If I had to pick one, is the federated resource allocation part, to continue to discuss with the different stakeholders and try to come up with alternatives and I would say even disruptive ways to approach, and we are very keen to get this going.
Okay, so thanks a lot. So next one, Michael.
Yes, I'm also going to go for the foundational years and really try and sort out the multi-year infrastructure level access to the compute data and network aspects. I mean, that's really top of my agenda for the next year and a half at least.
Okay, so thanks a lot, Sergio.
That's very interesting, because I wanted to mention as well for AGI the federated resource allocation, because also in our AGI federation strategy, that's to improve cross-border access, one of the key priorities. So it looks like we have some joint work to do here together.
Estela?
So just to be different, I would say cross-community developments for portability and having a sustainable plan for the investment on the software stack that makes this possible.
Thanks a lot. And, also one of the priorities of the SRIDA.
People.
Yeah. People.
Software expert that are able to optimize our software to meet goals. Sustainable. We have not touched on sustainability, perhaps this morning, or better usage of resources. I mean, we're provided whatever resources they want to provide. We have people that are enthusiastic to embark in utilizing them.
Okay, so this
maybe using AI or whatever.
This was tackled in the previous panel, in the technical.
You said this morning that people like to sit in front of a hardware, take nice picture, but they should take more picture with the people who write code. Right?
Okay, Pantelis.
If we add also the panel from the blueprint, I think we covered all actions. Maybe one that was not covered and involves people is governance. And I'm highlighting mainly because this is the challenge that we are now dealing with. So it's just coming from my immediate experience with the EOS Federation. You see all these different stakeholders, all of them with their different angles and perspectives and priorities. And it's an amazing kind of effort to try to come in a common understanding of a common vision. And effective coordination also at the very low and technical level, including notably, which I haven't seen very much discussed today, the legal aspects. So when you move from a forum or a light kind of coordination mechanism to an actual infrastructure that involves orchestration, interoperability, shared resource allocation, then you are moving from a non-binding collaboration to a legally binding, to a collaboration that includes legally binding aspects. And there is another, you are opening a completely different scope of necessary integration also at legal level of these organizations, which I find also quite interesting. It involves another type of people, but with their own expertise to come and advise us and tell us how to best move forward.
So the voice of experience, that's EGI that we have been delivering operational level services, we know like. Okay, so yeah.
Xavi, can I?
And Chiara, yes, of course. Sorry.
Thanks. So for me, I agree with Concetio people. We need persons, in particular, I think, career path. Taking into account that in this moment at European level there is the COARA initiatives, the Coalition for Advancing Research Assessment, that is, in my opinion, extremely meaningful in this respect. And taking into account also that the sustainability part is very important to be developed simultaneously, because for the new generations, it's it's a requirement that they will not go without the sustainability part strongly developed. We experiment this in France. I think that it's true in other countries. The new generation are requiring this sustainability even more than our generation.
Okay, now, thanks a lot, and sorry for not seeing you in the screen.
Don't worry. It's the problem of not being there.
Okay, so, and with Chiara's voice, so we managed to keep...
Okay, first we have heard many interesting insights from the two panels. Now we're going to hear a short recap. And Valentin and Andrea, would you like to join here? So we hear first, a recap from the technical blueprint panel by Valentin G. Blanchard, and then from the SRIDA panel by Andrea Manzini. And then we will move in a presentation from Chiara Ferrari and Valentin on the future of community of practice, and then some closing remarks. And after that, for the locals, we'll have some drinks, some final chats. Thank you. Valentin.
Okay. So this morning we had this session on the technical blueprint with the panel, and I will make a quick wrap-up of what has been said. So there are 6 main points, according to me. The first one is the top priorities, so it matches with the first question asked to the panelists. And if we have one word to remind, it's the word co-design. So the top priorities, according to several panelists, was to co-design by default with and within different scientific communities to facilitate adoption and improve the importance of the scientific community when we define policies, architecture, and solution. And we will see that there are different ways to do that. The second top priorities is to build a federated and coherent ecosystem, especially at the European scale. Design and form a community across European institutions, networks, countries, and stakeholders. It was Tommaso who said that it will be challenging to do that, but it is essential in the next few years. There are also other priorities highlighted, like interoperable authorization and authentication interface, the portability for the softwares and codes, the environmental sustainability, which has the technical blueprint has a dedicated section about it, the scalable infrastructures, and the adequate funding for research infrastructures. The second point is about the famous compute and data continuum. So I'm not very objective to say that because I was managing the community of practice of Spectrum. We'll present what has been done in the next session, but COP with multidisciplinary experts could help to build this compute and data continuum. And so Spectrum COP could be an opportunity to promote this concept towards European institutions. Issues relating to orchestration and workflows could be are important to be addressed for the compute and data continuum. The third point is about engaging stakeholders, so more or less linked with the famous co-design policies. So we need to be open and as widely open and transparent as possible regarding data and design with researchers, in particular because it fosters innovation, the example of the CERN and the WLCG. We need to make sure that policymakers receive and understand scientific recommendations. And another point about a relation between industry and science. So we still need to co-develop things together, but we need to keep in mind that we have not the same objectives. It's not the same time frame and the same investment frame, because I noted this example between parentheses. So industry needs to evolve fast, while science needs, above all, a trustable environment. We had this discussion about recruiting and retaining talent, So we need to recognize new career and stable pathways for research software engineers. We need to offer structured and logical career pathways rather than only high salaries that we cannot make it in this field, especially compared to big tech companies in AI, ML fields, etc. The next point is about best practices, especially taken from the WLCG experience. So it's especially answers from Maria and Tommaso. So I noted that we should be open to a bottom-up approach next to the top-down financing classical approach. We need to offer open source solutions because these solutions are publicly funded, and it also offers a boost of visibility. We need to invest in services, various services like networking. The multidisciplinary collaboration is also important, and also, again, this point of sharing information as widely as possible. We need to also leverage existing infrastructures. Oh, I lose my notes. Okay. I was saying that we also need to leverage existing infrastructures rather than creating new ones, so collaboration, co-design, etc. And there's a trigger warning about being careful with the comparison of WLCG because it started several decades ago with very different challenges in a time where artificial intelligence was not existing as we're seeing today. And the final point is about AI/ML considerations. So it was noted that we need to align AI development with scientific needs and differentiate hype from useful innovation. So we need to try to keep a rational perspective, especially compared to what is being done in the industry field. Again, the multidisciplinary collaboration can be facilitated by the arrival of AI agents, but only if they are trained with the right data. We can also try to develop more specific smaller AI agents, for instance, with the French company Mistral is currently trying to do. And last but not least, the training and skills is also a very important topic. We need to form scientific research software engineers who understand how AI works and not only just simply use ChatGPT. So that's all from the technical blueprint panel wrap up. Now I will let Andrea do the same for the SRIDA's panel session.
Thank you, Valentin.
Okay. Okay, so now we are going to the SRIDA panel recap. Okay. So I had not so much time to prepare the slides, so maybe there is something missing. But first of all, I know that, I reported here the main discussion points, so the main questions that were asked to the panelists. So first of all, the resource allocation across the continuum. So we have seen, that different scientific communities from WCG, LOFAR, SKA, they have like multi-decade computing needs. So they need for different allocation model compared to what is available in HPC or HPC side. But from the other side, if we change this to multiple years allocation, there could be an issue of scientific communities that can be left out for more years for this particular allocation period, because the main blocking factor is that, of course, the resources are shared. And then, we discussed also about possibility to harmonize the request towards national providers and HPC, so to help the allocation process. There was also discussion about AI across the continuum, the compute and data, how to bring requirements from the communities. So there were many panelists discussing about having collective lobbying to bring requirements. And then, of course, there was mainly discussion about the problem of low precision for the hardware, which is mostly a market problem, which will not likely change for a long period. We have seen that there are possible way around this. So first of all, there are calls in Horizon Europe that can be used in order to bring workloads closer to what the chips that are available now. And we have seen also that at the moment there are no funding possibility from Horizon Europe to build infrastructure, but there will be a possibility for possibly in the next work program for this, so that this could help also to bring infrastructure that are closer to the requirements from the scientific communities. And also Concexium was reporting that there will be the possibility to implement machine learning AI approach for simulation or study, possibility if it's possible to adapt the scientific workflow to loss of precision. But of course, this needs a lot of human resources in order to be implemented. In terms of governance, long-term representation, so the spectrum community of practice has been quite important for during the period of the project. They would like to continue this role, but in the case of LOFAR, this needs results in short time. And also, we could use for this existing coordination action, in particular for the implementation of priority for spectrum. So there are EOSC working groups, similarly in SFRI or NERIC, or in the case, or what has been implemented in ESCAPE. And then for the data and long-term preservation, we have seen that at the moment in HEP there is no bad situation. So there are different working groups for data preservation, and open data working group, where they study also different tiers of preservation, which includes also workflows and metadata. We have seen that, we discussed also that the technology advancement will help decreasing the cost for the long-term preservation, and that EOSC can provide the platform for to coordinate this activity. There are some projects like mentioning EOSC Eden that is doing this at the moment. And then there was a discussion about sovereignty without isolation. What emerged from the discussion, of course, that everyone agreed that sovereignty is only having different choices and not being blocked on a single dependency. This particular is, so sovereignty is, in particular data sovereignty, is now more prominent in other sciences than the HEP and, so for instance, life science and climate change. And we should collaborate with countries that put science first and not political agendas. And then the last one was like take one action home from the different panelists. So the majority they put as most important action the federated resource allocation, followed by the people, so availability of software experts to max code, and then also possibility to have cross-community development for software portability, but also the aspect of governance was mentioned, including the legal aspect. Okay, this was the recap. Thank you.
Thank you, Andrea. Okay, now we move to the presentation from Chiara and Valentin. Okay, we please have the slides deck number 5, please. So this presentation will be more about the experience of running a community of practice and the possible future of it. So Chiara will kickstart. No, you will kickstart, Valentin, and then Chiara will follow up with the second part. You can use this.
Thanks. Yes. So in this last session, we will talk about the famous spectrum COP and above all the future of the spectrum COP, because the project ends at the end of the month. So I will present what has been done during these 2 years within the COP, some examples. And then Chiara will present the main ideas, how to keep this COP alive beyond the project, why, and how. And then, if you have questions, we will answer to your question. So this is the last session of the day. So first, maybe a quick reminder of the definition of the COP. What is a community of practice? So this is, you can see the definition given by 2 anthropologists who invented the concept in the 90s. So it's a group of people who share a concern or a passion for something they do and learn how to do it better as they interact regularly. So this concept was promoted by the European Commission, notably through the COP playbook, which is a document published in 2021. It's a very big document who presents how to animate a community of practice within Horizon Europe projects. And there are several reasons in this document to explain why the European Commission promotes this concept. Above these reasons, we can note that It encourages continuous learning among different actors, including those outside the Commission. It values informal knowledge because it's an informal space of discussion. Not only what appears in classical project deliverables. It fosters alignment and co-creation without imposing too much hierarchy, because during the Spectrum COP, we were listening to COP members and try to adapt the COP according to their needs. And it's a flexible tool. So this is why the Spectrum Consortium considered this concept relevant, to try to bring together the two main communities, the high energy physics and the radio astronomy communities, with e-infrastructures, especially for developing the project's main deliverables, but not only. So now I will present you some concretely what has been done over the 2 years of the project. And the first example I can give you is the Knowledge Hub that we put in place to centralize information on the COP for all these members. So at the beginning of 2024, we organized with Tommaso, who managed the COP with me during the first phase of the project. We launched a call to join the COP. So members joined voluntarily following a call, and we were about 60 members. And also many external contributors also participated in the different, in the COP, as we will see in the next slide. So the Knowledge Hub is still online, so feel free to have a look. At the start of the COP, we implemented document repository through Confluence. It's a very used tool used in the two communities. So this one of the first action put in place across the 6 thematic working groups that Jeff presented this morning. And over 60 documents are gathered here. So again, feel free to have a look at all these documents which were useful for preparing project deliverables. To increase and structure member engagement, we organize also regular plenary meetings every 15 days, then every month. These meetings include presentation of initiatives of interest for both communities, and also informal discussion especially about the project news. So you can find on the Knowledge Hub the list of all the plenary meetings with most of the time the slides, so it can be also useful still today. The first survey was organized also during the first month of the COP. And this survey was co-designed with IENA, which is a discussion platform for nuclear, particle, and astroparticle physics community. This survey was created to support Spectrum intermediate deliverables. This survey adapted to the respondents' expertise, so it depends on your field of expertise. And we received more than 80 replies. And if you're interested in the result of this survey, you can check the D3.1 deliverables, which is available on the Spectrum website, and which presents all what has been done during the first phase of the project regarding the community of practice. Then, during the second phase of the project that Chiara Ferrari managed with me, we organized a public consultation, and it was the main activity of the second phase of the project. The goal of this public consultation was to reach new people for additional perspective. And it started with 10 individual interviews, which are listed here. So we had participants from radio astronomy community, high energy physics communities, infrastructure, but not only. If you see in the last one from Destination Earth. And the interview protocol were designed with COP members and also with my colleagues from Spectrum. During this public consultation, so it was the hidden phase of the public consultation, but the public phase of this consultation was launched in December 2025 via a webinar organized alongside the publication of the first version of the SRIDA and the technical blueprint. And a second survey was also organized to collect and formalize feedback. So you can see here that we only received 27 replies, which is a bit normal because all the respondents needed to read first either the technical blueprint or the SRIDA. So 27 responses were quite good considering the time participants needed to fill in the survey. Then for this public consultation, so as we said this morning, as we said earlier, in the SRIDA, 13 priorities were identified, and we organized a meeting for each of these priorities with Spectrum members, COP members, and also external participants. So we had 41 unique participants in total, with more or less 4 participants for each meetings. And feedbacks were organized asynchronously, so we asked people to give directly their feedback via documents before and after the meeting. And during the meeting, it was the occasion to present the concept, the project, sorry, and the issues of the COP. Last slide about the end of the public consultation. So we organized an in-person meeting in Barcelona at the beginning of February 2026. It was highly requested by COP members. So this meeting allowed informal discussions and roundtables about finalizing the main deliverables of Spectrum. And it resulted in a document available on the Zenodo and on the Spectrum websites. It's a very short document that you can read. It's a wrap-up of the informal discussion organized during this meeting. So these are some examples of what has been done during the COP to help building the SRIDA and the technical blueprints. And now I will let the floor to Chiara Ferrari, who will present the ideas and why we should keep this COP alive after the project. So I hope, Chiara, that you can speak. Yeah, perfect.
Can you hear me? Okay, perfect. So thanks a lot, and I try to check where we are. So can you, indeed, I will present the future of the COP. Can you go to the next slide, please? Okay, so this is just a slide to remind the 3 domains on which we have been working. As you have seen, the COP has been extremely active, and this was definitely essential for this interdomain project, because the COP was the place where we could collect, digest, and discuss all the information that then went into the 2 main deliverables of the Spectrum project. So it has really been an extremely important tool. On these 3 domains, high energy physics, radio astronomy, and e-infrastructures, now we need to understand the landscape. So next slide, please. In such a way to decide what to do next, because if you don't know where you are moving, it's very difficult to understand what to do next. So the landscape is a rich one. It's a landscape with here we have just selected to present the complex and rich panorama of research infrastructures, those on the S3 landscape roadmap, of course, and you can see in the 3 domains. These are not all, of course, not all the research infrastructures in the S3 landscape, but those on our 3 domains. Plus the ERIC structures again in the 3 domains. So as you can see, there are quite a lot of research infrastructures at European level. So next slide, please. And so this means that, of course, there is a variety of infrastructures, and in most of the cases, at the beginning it was just in some of them. Here we put in general all the research infrastructures in astronomy. We started in this project with radio astronomy. Okay, because it's the domain within the astronomical domain that has the largest data needs that are, as Michiel was saying before, it's in the present, it's not the future, it's what is already existing now. But more generally in astronomy, there is an increasing need. We know from high energy physics colleagues that this is exactly the same, and as we have been discussing extensively, we need to connect with the infrastructures to see how to use those. So the landscape first is quite a lot of research infrastructures to discuss with, and so quite a lot of communities to connect. So next slide, please. As shown here, there is a crowded ecosystems, and as we try to summarize, that need navigation and not application. This slide is for sure incomplete because we wanted to show at least some very important examples of what already exists in terms of coordination. Networks, here you can see logos of networks, clusters, consortia, association, platform or joint collaborations, again covering the 3 domains of the Spectrum project. And as said, there are more. So the COP, whatever we want to do with the Spectrum community of practice, needs to work in this ecosystem, needs to work with this kind of collaborations that are already existing, set in place, and very well working. So next slide, please. Having set the stage of the landscape in which we need to set up the COP, what is the role why we think that it's important to keep the COP spectrum, even if, as you will see, it will be a light activity that we would like to start with. There are different reasons, of course, and different roles that this community of practice can keep doing. So first of all, make existing initiatives visible to the community. Many researchers involved in the community of practice of spectrum are involved already in most or at least some of these research infrastructures and networking activities, but not all of them. And it's not sure that everybody is informed about what's going on at European level among these different organizations. And it's important to help experts to find the right contact points on one side, experts from a bottom-up approach, experts from the community who are interested to join networking or research infrastructures needs to identify the right contact points, but vice versa. Already structured initiatives need also to always increase the number of people and experts involved. And for instance, of course, in the domain of data-intensive science. Then, of course, the role of the community of practice is to channel the spectrum results into roadmap processes. And as we have been extensively discussed, what will happen in the future depends on a strong communication between different layers, the research community, the infrastructures, the decision makers. So, of course, the COP need to support the fact of really taking into account and bringing to reality the SRIDA and the technical blueprint in the future. The other very important point is that we all know how many new projects are starting, trying to put as much as possible together different domains. And so having a community of practice in which people can be informed about new initiatives that are starting, is important not to keep people out of important information. And so the idea is to have a light interface layer between communities, research infrastructures, and initiatives that are summarized in this slide. So next slide, please. So why then keep the COP after the Spectrum project? We know that it will require some work. So we could have decided to just stop it. We have been doing some analysis, and we have seen that many times COP have been created in other projects, and as soon as the project was over, the COP basically disappeared. We thought that it's important to keep the COP because the value of Spectrum lies not only in the final documents, but also in the expert network that shaped those documents. As I said, those documents really come from a lot of feedback input from the COP members. And so a light, really bottom-up structure of a COP can remain as a ready-made tool for our free domains to work together whenever it's needed, and also to be coordinated with other data-intensive communities. It was the ambition of Spectrum of already start to be much more connected with other communities. We started in different ways, through the questionnaires and so on, but we can definitely improve this. So next slide, please. What we plan to do is to preserve the bottom-up process and the expertise behind the technical blueprint in SRIDA. Once more, I want to thank all the people who strongly contributed to these two documents, those in the Spectrum project, and above all, those who were not directly involved as partners of the project, but who really fed, as Valentin very well explained, our documents. Next slide, please. Then there is the information part. We need to inform the community about opportunities, initiatives, and roadmap processes. And then the last part of the slide. Prepare cross-domain proposal to future European calls requiring communities to act together. We know that there are already ongoing discussions because more and more different domains need to work together in preparation of future European projects. Next slide, please. So we want to keep, as I was saying, we know that it's very difficult to, we are not naive. We know that it's very difficult to keep a COP alive beyond the funded project, okay? So it was already quite a challenge sometimes to keep the COP alive during the project, in the sense that in some periods of the year, the fluctuations of the numbers of participants in the COP was quite rampant. But that's why we decided to keep the structure deliberately light, but trying to give enough continuity to remain useful. So next slide, please. So first step is to update the charter. That means we have the charter for the Spectrum COP. We need to update it and to define how to keep it valid. Then next slide, please. Then we think that it would be extremely useful to nominate two chairs, one from the high energy physics and the other from the radio astronomy domain, to keep balance and direction. And this is, of course, very, very important. With possibly a third co-chair on the infrastructure's point of view, to have this link very well established since the beginning. Then next slide. So let me say that the role of Valentin in this COP has been key. Valentin has been the person following up with emails and reminding to people due stuff and so on, reminding the dates of the meetings and so on and so forth. So having a light secretariat, but at least for keeping mailing lists, sending documents, agendas, and organizing meetings, it's definitely important. So we will have to identify how to deal with that without dedicated funds. Next slide, please. Of course, to keep the COP alive immediately, it's important, because if not, if we now lose the interest of people, it will be very difficult to get it again. So it's important to start as soon as possible with by identifying relevant initiatives and connect the interested members. And so start as soon as possible to provide information about what's going on already now at European level in our 3 domains in such a way to have an immediate interest of the COP members. And last slide, please. And then we have thought that we need to maintain a constant rhythm with at least 3 meetings per year of the COP, and of course giving the possibility to have more meetings if needed. A minimum number of meetings is needed in order to keep the COP alive, and this kind of meetings should really be follow a bottom-up approach, asking to COP members to come out with important results, important requirements, progresses with respect to what has been discussed within the spectrum. But then other intermediate presentations could be added during the year, indeed, to present important initiatives that are ongoing. So this is, I think that this was my last slide before starting with questions. This is more or less what we think about the interest of maintaining the COP and how to do it. And of course, we, as I said, we are aware that it will not be an easy task. So we are more than welcome to receive your, we are more than happy, sorry, to receive your feedback. Thanks a lot.
Thanks a lot, Chiara. I don't know if we have enough time for some questions, if there are any, of course.
A bit tight with time. I don't know if you have any burning questions.
Okay, so if
otherwise, okay, we can postpone the chat in the drinks part. Thanks a lot, Chiara and Valentin. And now the very last. I see also the energy is fading, so let's wrap up this long day, very interesting, and where we saw the these final results from the project, the SRIDA technical blueprint, and the community of practice as a living results from the project. Can we please have the slide set number 6 so we can wrap up? Just some very closing message. Security alert, okay. So first of all, we start with this leading question. That was a leading question that brought to the design of the project and until this long journey of 30 months. And as we mentioned, these are the 3 key results we leave, and the technical blueprint, the SRIDA, and the community of practice as a living results for us further to use and nurture in the community. As a community, I mean, as a consortium, we are committed to continue the collaboration, follow up on actions, and we also hope you will help us to advocate for the results of the project within your own organizations and channels. We received many suggestions today, also like where to continue and promote these results. So we heard about the advisory boards within the EuroHPC, with the commission, through the DG RTD unit. It will be a useful input for them also to propagate the results and the recommendations within their own internal channels of the Commission, so that goes more into the policy making, and so on. So this is a collective effort. We have many actions from many stakeholders, and we hope that in a few years' time, we will see this vision of this computer and data continuum for data-intensive science a reality. And before we leave, okay, this I mentioned with you like lives, like about unforeseen situations. This is what happened last Friday. That was our printing facility. The hailstorm didn't make it happen, but okay, if you want to read the positive sides also in very unlucky events, this means that we can print to you the very final version of the SRIDA at the end of the month. So if you're interested in getting it, please fill the form. And because the SRIDA will be finalized and closed at the end of the month, while the technical blueprint is already final. The other key asset we wanted to show you today was the short clip. And let's see from the our technical support if you manage to show the video now. I think it's more on the back to. I think, okay, they need to, if you manage, otherwise it's on the website, but okay, if you can show this very beautiful screen, it would be nice.
Sergio, if I may just, a small addition, for project partners, especially at the door, there's more materials like flyers, stickers. Please take with you for dissemination at future events. Also, if you're not a project partner and you want to take some, the more you take, the less we have to carry back. So I'll be very happy.
Can you put the audio also? Okay, maybe it was not downloaded. Anyway, the one on the YouTube is also with audio. And music. We can sing, yeah. Yeah. It's more like a video game. Okay, this we need to. Anyway, while this completes. Okay, it's almost done, so let's wait. These are the stakeholder groups.
If you want to promote the project in some way, you need like a raw file or something, you can always send me a message, because like you might want to take it to an event.
Okay, thanks a lot for your lively participation for today. Thanks to all the speakers, the panelists, and you for coming here, and hope we will bring some very good insights for the future work. Thanks a lot, and now we are going there in the room for the drinks. We have 1 hour for drinks and some food. Thanks a lot.
Bye.
Bye-bye.
Hi, Chiara, and thanks to the remote
I will drink alone.
Virtual toast.
Bye.
Ciao, Chiara.
Ciao, Fabio.
Ciao, grazie. Bye-bye.